Hi everyone, and welcome to Mr. Carlson's lab. Today I'm going to go through this Motorola radio receiver and make sure that it has been electrically restored properly. If it hasn't been electrically restored properly, I'll take you through the entire correction process, repair process, and make sure that it has. At this point, I really don't know if it has even been restored. Judging by the case, I would imagine that it probably has, but we'll discover that together when we take the whole thing apart and look on the underside of the chassis. Judging by the line cord, it has the original line cord and original non-polarized plug, so maybe it will need a full electrical restoration. We'll find that out here in just a moment. Whoever did the restoration on the case, as you can see here, did an absolute fantastic job. The paint job on this is an automotive quality finish. It's like a mirror. And that green color with all the detail, you shine a light on this from across the room and the thing just glows. On the bottom side of the radio receiver, it has a metal bracket here, and you can see that they've added a smoke effect, and it looks like they've cleared over that, as well as the knobs and the pointer on the front as well. I have a still photo of this radio receiver. Let's take a look at that. Under a little bit better lighting, you can really see how that paint just jumps right out. I would honestly have to say, I think this is probably one of the nicest painted All-American 5s that I have ever come across. And if you've been here for any length of time, you'll know that I've come across a lot of All-American 5 and All-American 6 style radio receivers. After I've gone through and, of course, corrected anything that may need to be corrected, I know this definitely does. After that, what I'm going to do is install a Bluetooth modification into this radio. I've designed a circuit board that allows for a very seamless install in any All-American 5 and All-American 6 style receiver. And it can also be removed down the road if so desired and basically leave almost no trace that it was ever installed. So it's very easily reversible. I'll share that entire process with you as well in this video, and you'll get to see that little circuit board that I've designed too. So lots of great stuff and lots of territory to cover in this video. So let's get started. In order to get this radio apart, it really is quite simple. You just take the dial pointer off and take the two knobs off the front. And then in the back, you don't even really need to take the cardboard back off. You can just undo these two screws and the whole chassis should come out. And it's very standard for most all of these All-American 5s. They pretty much all do that. Of course, there are a few exceptions that don't, but pretty standard. So obviously I want to get this thing out of the case and get the case off the desk completely, because as I'm moving around with screwdrivers and have a hot soldering iron and things around here, I don't want to be touching the case or destroying the paint at all, because the paint on this thing really is just phenomenal. So while I'm here, I want to show you one of the safety things with these non-polarized cords. And a lot of people seem to think that this really isn't such a big deal. Okay, so what I'll do is, now, I've said this many times before, that these should always be restored before, they're plugged in, or you need to know the status of the radio, because if the filter caps in here are bad, what ends up happening is the rectifier tube will go away. So it actually takes the cathode bonding wire off, the little cathode strip, and I'll show you that here in a little bit. It actually destroys the tube. But I have lots of them, and I'm going to do this here as a demonstration of the possible issues that could arise if a polarized cord is not put on these radios. So this is a real important safety improvement. Let's discover this together. So I'll plug the cord in this way into the outlet, and then I'll remove the cord and then turn it around and plug it in the other way. Okay, so I'll just plug this in under the bench here. Here we go. And I'll turn this on. And I will turn on the radio. I don't know if it's on or not. No, it's on. Okay. Okay, so the radio is on right now, and whether it's going to make any noise, I really don't know, but we'll find out here in a moment. So now, I'm going to take a standard indicator bulb. So this is a, standard indicator type light bulb. And, oh, it is humming. And there is a bit of noise in there, so that is a good sign. So it is doing something, so that's a good thing. Okay, so now here's where the issues always lie. Okay, so I'll back this out just a touch so you can see this. I hear chunky static noises, which isn't a good sign. It's usually caps or something, maybe a resistor tube, I don't know. Okay, so most all devices that are, like a piece of test equipment or anything, have usually an earth connection that connects to the case. And of course, here's where the issue lies. So I'll take this jumper clip and I'll say, just clip it to the, that's called the bat handle toggle switch. So I'll put it on the bat handle there. All right, and now what I want to do is go around here, and you can see that there's two exposed connections here where the antenna would connect, and you can see the back here where this would connect, say, to the actual chassis of the radio. Sometimes these are isolated because back in the day they knew people would try to attach the chassis to a water pipe or something like that, and for a radio like this, that's a very dangerous thing. Again, I'll show you here in a moment. So let's see what happens here if I touch this indicator bulb to one of these antenna connections. So the way that these are wired is usually this will light if either the radio is on or off, depending on which way I have the plug plugged in, and I'll explain more about that in a moment here. So let's see what's going on here. Okay, there you go. You can even hear it in the speaker. And I can hear the AVC is working. So the AVC line is working, but it's very slow. So I'll give you an example of the AVC line, what I'm talking about. You hear the static? So right now, the AVC line is open and it's trying to receive. So when I do this, see how it's quiet? And it came back up again. So it's charging that AVC cap. And then of course that AVC cap had to drain off in order for the receive to come back up again. So anyways, the AVC line in the radio is working, but as you can see where the hazard would be. So a lot of people, what they do is they put a switch in the back here for a Bluetooth connection, all right beside these things. Now, what would happen if you were, say, holding on to this and you stuck your hand on there? Look what it's doing to this 120 volt light bulb, right? So if I was holding on to this and I went like this, you already know what would happen, right? Right? So I'm taking this and putting this obviously between there, and you can see it's lighting this bulb up. Now, what'll end up happening is I'll take the outlet out of the wall and I'm going to reverse it and I'm going to plug it back in again, okay? So now I've plugged it back in again. So now what I've done is I've reversed the line cord. Now, basically what's happening is the neutral side of the line cord is now connected closer to the chassis side. So it's actually reversed it. So now if I do this, look, nothing. And that's what we want all the time. Now here's the problem with the wiring in the radio. It gets pretty deep, and I'm going to explain this to you on the schematic. You hear the radio's on? Now I'll shut the radio off. So now the radio's shut off, right? You'd think everything is okay, right? Now it'll get you when the radio's off. Again, I'll turn it back on. So this is something that really needs to be understood about these older All-American 5 and All-American 6 radios, and there seems to be a really big misconception about this. And whenever these things are gone through, this needs to be addressed. This isn't something that should be left alone, especially if you're going to put a Bluetooth switch on the back, or if you know anybody can reach around the back and actually touch anything. Oh, what I should have done is, right now it's off again, right? Yes, so if I touch this, yeah, so they've isolated this. So this is isolated. So that's a smart thing. A lot of radio manufacturers did that because they knew people would always try to ground the chassis to get better reception, while doing that with one of these radios, again, is a really big problem. So now, what we'll do is we'll take a look at the schematic here. Now that I've shown you all this neat stuff, I need to show you why it's doing all of this and why it's so important to correct this. So we'll move this here. This out of the way just a bit. I don't want to hurt that cabinet. I'll zoom you into the schematic here. So this is a schematic for that radio. And as you can see here, I'll grab something to point with. So as you can see here, we have the line plug and it says AC or DC. So you can run this on direct current. So basically if it doesn't work one way on direct current, you reverse the plug and it'll work. That was a standard thing way back when. So this can be run off of batteries as well if you can, create 117 or 120 off of batteries. Anyways, you'll see that we have a switch here. The little X is a switch, and if you follow that out to the lug, it runs down here and it says B-. All right. So what they're doing is they're opening the B minus line, or in this case, this would be the neutral line. They're actually opening that neutral line. And as you can see, this runs up here, and this is the B minus, or the DC ground for the inside of the receiver, all right? Once it goes through the rectifier, this is the DC ground. So they're opening this switch. So what happens here so say this here is the neutral side, and this is the hot side, okay? So if this is the hot side, when you turn the switch on, it's attaching the hot side to here, and we have the hot on the actual, the negative wiring in here, and it's coupled to the chassis through this cap here, and that's what we're getting enough current through to light that bulb, all right? So when the actual switch itself is on, and we have hot on this line here, that's when we get the light up of the light on the radio receiver here, when we touch this little metal antenna connection on the back, all right? So that's when we actually get that effect. When we turn the radio off, of course we reverse the plug, now we turn the radio off and we get that effect. So what's happening here is now what we do is we have the hot line on this side here. So the hot line is on this side, and as you can see, if we close the switch, we bring the chassis closer to neutral through this capacitor. All right, so when we close the switch, so when the radio is actually on, we bring the chassis closer to the actual neutral through this capacitor so we don't get lighting. But when we shut the switch off, it opens the neutral connection. So if it opens the neutral connection, we have the hot side connected to the filament section here, going through all of these filaments right here, and then running onto the neutral, because this is open now, right? So this whole thing is now hot. And that's why it lights that bulb up when we turn the outlet around when it's off. So this needs to be changed. This is one of the biggest safety things that I always stress about this, and I even put a fuse in line with this as well. So this needs to be fixed as neutral. So the wide blade of the plug, all right, in most cases, unless your house is wired, very interesting. You always have to know about that too, because many houses are wired incorrectly. But the wide blade in the plug, the neutral side of the plug, needs to be fixed onto this line here, and it shouldn't be broken. The switch needs to be removed from this line and put into the hot line here. So when you turn the radio off, it cuts the hot line only, and the thing always has the neutral side attached to the chassis. Now, depending on the code and where you're at, in most places, in your breaker panel, the neutral is attached to the earth ground. All right, and of course this depends on where you are, but where I am, this is it, and in many other places they do that as well. So again, in many places, not all, but in many places, depending on your electrical code, the neutral is attached to the actual earth ground in your panel. So this is very close to the earth ground. All right, that makes the radio much, much, much safer. And it's a modification. If you're ever repairing any of these radios here, it needs to be done, especially if you're going to be passing this radio on to anybody else. All right, if you know the situation and the dangers and all that of having an All-American 5 radio, and the exposed, again here, exposed metal on the backside of the radio here, and sometimes again these are even connected to the chassis, for your own purpose, if you know what's going on and you're comfortable with leaving it the way it is, that of course is always up to you. But again, this radio here has obviously been through a few hands, and as we can see, we haven't even opened this thing up yet with a simple light bulb and a wire connected to a bat handle toggle switch on an earth grounded piece of equipment over here, right? It's just a jumper clip attached to this, right? So you can see that something a test as simple as that really shows that we do have some issues in here, and of course that hasn't been a problem that has been addressed. Real important safety thing to always keep in mind with all of these radio receivers, All-American 5s and All-American 6 style radio receivers. So that's a problem that we're going to have to address. That way, again, when this is modified, on or off, the chassis will, and the connections on the back of the radio here, these connections here, will be close to chassis. And that makes things way, way safer. So back in the day, it was just standard to do these things. Again, the reason that they did this is because these sets would both run off alternating current and direct current. And of course, in some cases, depending on which way you plug the plug in, they were more concerned about radio reception than they were concerned about safety back in the days. So just something to keep in mind. All right, let's get this radio apart and see what's actually been done to it, if anything actually has been done. Just get this out of the way where I'm not going to end up damaging it. Hard to maneuver around the camera here, so. The top side of the chassis looks like, you know, somebody's obviously put the time into this. Speaker itself looks like it may have a small puncture there that somebody's tried to fix. Other than that, let's see if it's... There's no binding, so that should be just absolutely fine. It really does look like somebody's cleaned this up, or it has been in a very clean type of atmosphere. So let's take a look at the bottom side. Well, here's the bottom side of the chassis, and it definitely looks like somebody has been in here and put the time in. So we can see all the replacement caps here. This thing here has a little hybrid. They're known as hybrids. Sometimes they're called PCs, and sometimes they're called couplets. They have all sorts of different names for these things here. So anyways, what this thing is really, it's like an early passive type integrated circuit. It's not active like, you know, say an actual IC, like a 74 series logic IC or something like that. It's not an active part, but this is a passive circuit. So lots of resistors and capacitors are put inside these things in order to, you know, save lots of these larger parts. So yes, early 50s IC right here. Kind of interesting. So somebody's put new filters in here. So that's probably one of the reasons it didn't destroy that rectifier. You can see the line cord here is probably close to being original. So it still has the knot in here, and line goes right to the switch. And then on the other side of the switch is the standard neutral connection. So this will run off to the neutral here. And then this one here would run over, and this would be the hot connection. So right over to here. So this is the line that would have to be moved. Technically, this here has to be moved and affixed to the ground off of the switch. This here has to be attached to a fuse block, and then from the fuse block run over to the switch, and then from the switch back over to this connection right here again. So that's the modification really, in order to make this radio quite a bit safer. The capacitor that attaches from the neutral side across the line here. So this should be an X1 Y2 rated cap right here. This is just a standard cap that's been put in place, which isn't a good thing. So that will be replaced. Now, mind you, there is going to be a fuse block in here, and if this cap was ever to fail after this scenario, so after I install the fuse block, it would just take the fuse out. In this case here, if this was to actually short, this would make quite a large pow noise, and there would be some smoke emitted. So this component here is not designed to fail the way an X1 Y2 rated cap is. So this cap here, since it's across the line, when you close the switch, when you turn the unit on, so it's off right now, when you turn it on, it's actually putting this capacitor across this and this right here. And again, there's no fuse at this point. So again, if this capacitor was to ever go away, it doesn't fail in a very safe mode. It will fail in a mode that will, provide smoke and a large noise. So let's take a look here. I'll show you on the schematic here again. So if we look again at the schematic, you can see that this cap here is running directly across the line. Now, when the switch is on, right, so when this switch is closed, of course the line from the plug is attached, and again right across. Now, since there's going to be a fuse and a switch in this line, again, what will end up happening is that if that cap was to ever go away, it would just take the fuse out. So again, another important safety thing to have, I always add a fuse, especially if when the radio is my own radio, and if I want to keep it perfectly original, which we can see that this radio is definitely not already, that's one thing. But then the radio becomes more of a thing called a shelf queen. So you look at the thing, and I usually put a tag on the AC line cord on the outside of the radio saying no fuse and the neutral system not modified. So that way down the road, if I was to ever say get rid of the radio, I know, okay, I'm not going to do that, because I would have to go through it and amend those issues first. I would never ever want to have one of these radios leave my possession in an original condition if somebody had intended on using it as a radio without these modifications that I'm about to do here, because again, this really is an important safety improvement for all of these radio receivers. And as you know me here on Mr. Carlson's Lab, I'm all about keeping things as safe as possible. And it's not being unrealistic. As you saw, we can light a 120 volt light bulb off of this connection that's just exposed right here. And in many cases, again, these connections are exposed, but we can see here where they've added the insulator. There's an insulator under this screw here, and there's also an insulator under this tab, which turns out to be this little phenolic strip that they've put in here. So they've done this, again, because they know this, and usually they've worn on the back here too. Do not connect antenna or chassis to a water pipe, radiator, or other ground. So they're already telling you this, right? And they're trying to give you a hint up here. No external antenna or ground wires needed, right? And that was because this is equipped with a very fancy AeroVane high efficiency loop, which is just a loop antenna, nothing very special, right? All these fancy things that they tried to say back in the day, it's just all standard stuff. So that's the thing. So I need to get in here and put the fuse in and remove all these wires around. So what I'm going to do is put a small hole in the chassis on the top side, and I'll put a standoff in here, and I'll move all of the connections that are on the far side of the switcher onto that standoff, so I can free this switch up. You'll see that they've also connected the ground side of the potentiometer, the common side, to this connection down here as well. That'll all have to be moved down here so I can free this switch up completely. And then at that point, this will become, of course, the hot will come in, go through a fuse, from the fuse over to the switch, from the switch back over to here, and the neutral will be affixed to that tie point down on the bottom. The way that they've actually done the restoration in this radio, they've done the J-tag, J-hook, I should say, not J-tag, J-hooking method. So anyways here, talking about getting into circuit boards and ICs and stuff like that, J-tag, right? J-hooking method here. So what that is they cut the old component out. This is very commonly done when people don't have a very hot soldering iron, or they just don't want to actually remove the component from the lead itself. So what they do is they cut the component's lead off. So they'll actually trim the lead of the old component and leave a little piece of it sticking out. And then what they do is they hook the end over, and then with the new component, they take the lead and they hook its end and they put the two leads together like this, and then they solder them together. And that's what this is right here. That's what that little ball is. I don't know if I can't get my lens any closer to that, but anyways, that's what that little ball is down there. It's known as the J-hooking method. I really don't like that. You can see it's done over here as well. I really don't like that. I think it doesn't look very good, but again, that's a personal thing. That's just, I mean, look what they've done over here. I mean, look at that. That's just, look at that. You know, and there. I don't like that. I think it's just, I think that's sloppy workmanship. That's just me though, right? So whenever I replace any of these caps myself, I'll run the lead right into the socket. There's no reason to not to desolder it right from the socket. The sockets are tough enough. They're so tough, you can even leave the tube in and do it. I've done that so many times. Leave the tube in the socket and just do all the desoldering and connections. You don't even need to remove the tubes. I've never, ever damaged a vacuum tube doing that. And for all of you that are new to vacuum tubes, touching the glass is absolutely fine. It's not a quartz bulb. That's another really big misconception about vacuum tubes. Now, you don't want to touch the glass when the tube is on, because the tube is hot, right? These tubes are blazing hot when they're in service. But when the tube is cold, right, you know, the glass is just like standard glass. It's not like a quartz glass or anything like that where, you know, they say you're not supposed to get your finger oil on it or anything like that. Not the same thing with a tube. This is just standard glass, not a big deal, All right, so don't let that misconception fool you. Anybody that tells you that you can't touch a vacuum tube when it's cold, touch the glass on it, instantly that just, you know, tells me what they know about vacuum tubes. All right, and now you know, so don't get fooled by that. Okay, so what I'll do is I'll start getting some of the components installed here, and when I've got the neutral system all fixed up here, I'll show you the modifications and explain it all, and we'll get into maybe some component testing, make sure everything is good underneath here, and get into that Bluetooth install here, get that in here. All right, I'll get rid of the line cord. Of course, the line cord is unplugged, and of course it's been unplugged through the entire explanation here. So I'll just get rid of this, get rid of that, and can completely pretty much just remove it at this point. Get that right out of there, right? So take the line cord right out and just put this off to the side, throw this in my line cord bin. It's kind of a neat, no, I have the focus fixed here, this kind of a neat old plug on the end, so I really like to keep that. And start removing some of the components on the bottom side here. Hopefully you can see all this. Let's make sure this focus is touched up perfectly here. So heat this up and pull the line cord out. So it looks like it has been replaced because it is not wrapped around the actual switch itself. And over here, usually they wrap the actual line cord. Yeah, so this has definitely been replaced. This line cord isn't an original, or it's been shortened or something like that. So get the line cord out of there completely, and that allows me to get in here and start working on everything else. So what I'll do now is just desolder, remove the solder from these connections on the bottom here and get them ready for reinstallation. Again, I have to remove everything off of this bottom terminal here as well, and of course elongate this down to the standoff on the bottom here. This is going to have to come off as well. I'll show you why here in a moment. Another thing that was overlooked in this restoration. So if we look on the underside of this cap here, see how this cap is touching the chassis? So you can see how it's isolated here with these rubber grommets, but it's touching the chassis here. This is an RF ground. It's different than a normal DC ground. So the reason that this is basically stood off this chassis with a bunch of rubber grommets is because on the bottom, the ground connection has to connect to the ground over here. It can't connect to chassis ground. And they do that to stop the thing from oscillating and from creating different issues in the oscillator section. That's why this ground is different than this ground. So these washers, the grommets, as you can see, are just, they've turned to glass almost. This is just completely decayed. So that'll have to come off. I don't know if at this point I'll have to remove the dial string in order to do that. It is a more complex dial string system on this, just the way that it's put together because of the speaker. There's even cutouts in the plastic in the case. This has to travel through a cutout in that nicely painted case in order for this to get through the speaker cowl inside there, but kind of an interesting system. At any rate, I'll see if I can do that without, having to remove the dial string. I've noticed here that this is supposed to be aligned to the stop. So if I grab this and turn this all the way to this side, that should be hitting the stop, and it's not. Whereas if I tune the dial, there's another stop on the other side. You can see the stop right here. If I turn this way, you can see that it hits this stop. Well, it's not supposed to hit that stop, and as you can see, the capacitor is not fully open. See, it's still meshed on the bottom there. It's still slightly meshed here. That is a big problem to get us right up to the top end of the dial. So it's supposed to be the actual, this is supposed to be resting on this stop for the alignment, so it may need a new dial string anyways. Picky dial string setup, as I mentioned before, but if I go through and have to replace that dial string, I'll take you along through the process, and of course, hopefully we have progress. So anyways, yeah. So that's what's going on with that. So now what I need to do is, I'll move the back. You know what they say, the longer you look at it, the more things you'll spot, right? Well, this is no exception, so I'll just get rid of this right now because I don't need to worry about this on the back. Just get this thing out of the way. And that frees things up in the back here. And of course, the reason I'm doing that is because I have to get a drill in here in order to put a fuse holder in this section over here. So it's not very specific. Again, I just want to have this in an area that, you know, relatively close. I can move this out of the way. It's a little bit more free in that area there. I think I may actually just mount it further over here. So again, you know, not very specific. So I would say that it's right about there. Just looking at both sides here, trying to size things up, give it a bit of tension. So I'll need to put a standoff on the bottom side of the chassis right back here that's just past the back side of the switch. So I'll remove the tubes to do this because when I'm drilling here, there's going to be little metal shavings that are probably going to get under the tube sockets anyways. So I'll just take the tubes out and put them off to the side here. Again, I'm not really worried about damaging them through vibration or anything because nothing like that's going to happen. But right about there is about far enough back, I think, right about there. And this is just a little bit of a twist here. And I'll move this over because the way I'm holding the drill on camera here is kind of a scary thing. There it is. There it is. Again, you know, you want to be careful because what ends up happening is that, you know, if you put any type of pressure and you don't feel it, so I always slow down. If you don't feel where the bit is at the end, you'll end up going pop, and then of course you ram the chuck into the radio and do all sorts of crazy things. So now you can see under here, that's right where it came out, and that's perfect. That's exactly where it needs to be. So it's not right under the switch. It's off to the side there. It's kind of hard to see its position here. Over here I can see it clearly. It's actually quite a ways over from the control, but it just depends on which way you look at it. And there's lots of clearance there to the switch. So I'll get that standoff put in and move some of these connections over and clean this area up. This is just, yeah, I don't like the looks of this whatsoever. I may even replace these caps with a high quality cap. So since I'm in here, I may as well, you know, go do the full meal deal here. So anyways, I'll just, yeah, probably go about clearing all this out and redo this all over again. I've moved some of the components out of the way just by trimming them off because I feel like, you know, I'm just going to end up replacing these anyways. So put something in there that's going to be good for the long term. Vacuum the solder out of these things here. You can see a little hole that's in there now. So I'll have to clean all the rest of the wiring out. That cleans that out really nicely as well. There's that, and of course all the rest of the connections need to be cleaned off as well. So I need to get that little wire piece out of here on the bottom, which is nothing more than a clip and a little bit of persuasion with an actual soldering iron. So that's what they do. I'll just adjust the focus here so you can see this a little bit better. There it is. So a lot of the times people are folding things around here. Like all of this should really come out. So I'll give that a bit of a clip. See how that just basically falls off now that it's been desoldered, right? And they've got this one extra wire here from the common lead of the potentiometer that will need to come off. That runs down here as well. So that's nothing more than really a clip at the bottom and then a bit of a desolder. So that should be absolutely fine now. Now what I'll do is grab just my normal soldering iron here. Of course this is going to fall into place, right? And that should just end up removing. There it is. So now that that's out of the way, see that down there? You can see this is left just a little chunk on the bottom here. Anyways, that'll come off with a normal soldering iron. I can get that little loop off there. And I can feed now the new wire into here from the line cord. And then of course this will run back off again. So I don't know if I can show you this, clear this off here while it's still on. So what they do a lot of the times from the factory is they wrap this around so many times you get loops on here. You can see that? Still wrapped around. So what I like to do is clean all of this just right off. You see that? Now that's pretty clean right there. Clean that all right off and then just start. I don't want to do any of that J-hooking method or anything on here. I want to just have everything right to the terminal and a nice clean install. The switch modification is now complete along with the installation of a brand new polarized line cord. So the neutral side of the line cord runs over to this post over here. It can no longer be switched in and out of circuit. It's fixed to this post. Of course, this post is the B- for the entire radio, and the B- is closest to the chassis. The hot side of the line cord runs up to this fuse, and then of course through the fuse and over to the switch. So only the hot side of the line cord can now be switched in and out of circuit. I'll do a demonstration in the end of the video again here with that little indicator bulb, and I'll attach it to the antenna terminal on the back side of the radio, and I'll turn the radio on and off, and I'll show you that that bulb will no longer light. Again, big safety improvement that should be done to all of these radio receivers. X1 Y2 rated capacitor is now installed across the line here. I took the time to replace the two filter capacitors with much higher quality capacitors. These are Rubicon 105°C rated caps, and they also have a very high hour rating. So these will operate for extended periods of time at very high temperatures, of course, which these will never see. So even the voltage of the cap is really overrated. I have a feeling that these capacitors here will be the last capacitors, last filter capacitors that this radio will ever see. The ones that I removed, I really don't know the quality of them. These are only 85°C rated caps. And yeah, so got rid of those. Same with the poly caps here. You'll see they have a rating on them, but no name. So they're just kind of no-name caps. So I got rid of all those and I installed Illinois caps all the way through here. I also took the time to indicate the foil side off camera here. And for this capacitor here and this capacitor here, it's relatively important. For the rest of them, not too big of a deal. So you can see an audio line's running right across this, and we have IF transformer leads right across the top side of that capacitor there. So we want to keep the shell of this capacitor at B-, and of course the same with this one here. I want to keep the shell of the capacitor at B-, again because of this long lead they've got running into the little PC here, or hybrid, or whatever you want to call it, couplet. You'll also notice that I've replaced many resistors in here as well. There's a couple of originals that have been left behind here. Well, actually a few more. There's 2 dog bones that have been left, and these ones here are left, but most of the rest of them have all been replaced just because their values have moved a little bit too much. I would say the worst one is probably the AVC, or if you'd like, automatic gain control line. It's really what it should be called. They call it AVC, but this is really controlling the gain. So this resistor in combination here with this capacitor here set the AGC time constant for this radio receiver. So this one here was over 1 megohm high. So it's supposed to be 3.3 meg. The other one was, I think 4.5 megs, something like that. So way up there. So that needed to be replaced And of course that'll affect now the sensitivity of the radio receiver. It'll make their radio, I should say, react to stronger signals better and faster. So of course this is going to need a complete alignment once this is all done. I'll take you through that procedure as well in the end of this video. That'll be after everything is all done with the radio. That's the very last thing to do before it gets put back in its case, because if you do an alignment and then move anything around in here, it'll throw the alignment off again. So that'll be done after the Bluetooth modification and everything is done. So really the next thing that I need to do here is replace the grommets on the bottom side of this tuning capacitor here. You can see it's even, you know, tilted over like this. So it's, yeah, these grommets have definitely seen better days. Looks like they've almost melted. You know, they're in pretty bad shape there. So in order to do that, I'm going to have to remove the dial string here, and I'll probably just put a brand new dial string on this. And of course, that'll allow me to remove this tuning cap. I'll probably have to desolder the oscillator coil here and all of that as well. So a little bit of work ahead of me here, and I will take you along through the process. So I guess the next thing to do is to remove the dial string. Before removing the dial string on a radio receiver like this, you're definitely going to want to take some pictures of this, even if you have the dial string layout right here. All right. So this is the dial string detail, and it can be found on the data sheets for these older radios. But sometimes you're looking at it a certain way, and it doesn't illustrate how many times the dial string will go around one particular pulley in some of the diagrams. So I always take multiple pictures of the actual pulleys and, you know, how many turns they have down here. They specify fewer turns, which tells me that this has probably already been replaced. And I do notice that the spring is mounted on the top, whereas in the replacement, they've mounted it on the bottom. So probably a replacement dial string at some time. I know that this is very hard to move, so this should be a very smooth, like when it gets to the end here, it gets really hard to move. So a lack of lubrication in there, and of course everything needs to be cleaned here as well. So that gives me a good chance to do all of that, remove the bracket, and of course, you know, clean everything up. So what I'm going to do is I'm going to cut this right above the little knot here. So I'll zoom you in so you can see that. There's a little knot here where they've tied it onto the string, or onto the spring here, the spring to the string. And so what I'll do is I'll just cut one of these, or actually I'll cut both just because I'll probably, well, maybe I'll just cut one, and that way it'll hold on to the spring so the spring doesn't go away. So I'll put this here. I'm just going to put this down because the spring is probably going to release tension there. Okay. And now that that's done, I have lots of pictures of this, so I can just remove the dial string. Now you don't want to throw the old dial string out. Reason being is you want to measure it. So take this all off, and you have the entire length. So what you want to do is cut your new piece of string, maybe another 6 inches longer than this. So I don't think I can back this out far enough for you to see the entire length of the dial string, but you want to cut it about 6 inches longer for replacement. That will give you some wiggle room. And, you know, of course, you can always cut the excess off. If you cut it too short, that becomes a real pain. So what I usually do is I have 40-pound test fish line. So I'll just go grab that right now. I have a bunch of different types of dial strings that I like to use, but the 40-pound is pretty good stuff here. So this stuff here, it looks almost the same. And of course, you can pick this up at any sporting goods store, and it's virtually identical to this stuff. So it looks original and everything. So this is what will be used to put the new dial string on here. So I'll just move this off to the side where I'm not going to lose it. So that's out of the way. Now what I need to do is remove this capacitor here. And of course, I need to desolder the oscillator coil from the bottom here. So I'll get a soldering iron warmed up, and we'll start removing this and take these screws out of these very, very crusty grommets. Wow, this is becoming a pretty in-depth little restoration. So lots of stuff to do here, and haven't even begun the Bluetooth mod yet. So I want to be very careful with all of this as well. And I also don't want to move these leads around very much. So reason being is, of course, this oscillator coil is a little bit fragile, and the leads are, relatively tough, but it is a little bit fragile. So unfortunately, the nut is right underneath this, so I'm going to completely have to remove this, of course, and be very careful. A good thing to do is to actually read the resistances of the terminals before you remove the oscillator coil. And that way, if you put it back together, you can read them again to make sure you have all the same resistances so that you haven't opened one of the little wires off the lead-in leads. That's a really good thing to do. If you know the radio works before you do this kind of stuff and then you put it back together and say it doesn't work, there's a good chance that you've, obviously damaged one of the leads in there. So just a little hint to make life a little bit easier, because a lot of the times they don't actually specify the resistances to this. So they were actually pretty good with this. I'm going to have to use my other desoldering tool for this because it's way down there. And these leads are really hard to bend. I'm going to be wrestling around with this a little bit, so I just pulled the tube out. Again, they are very tough. A lot of the times you can leave them in, and if you do forget to take them out, it's not going to be too big of a deal. So the reason that this doesn't want to come out is because this is bent around here. So you don't need to rebend these back in place again. So what you can do is, usually what I do is I move these around, make that loose like so. And then I'll cut the lead just a little bit shorter, so when I resolder it, I can solder it back in there, but I don't want to be putting bends in this all the time as I'm doing this. So now the only bend is going to be basically bending it forward and pushing it back in. And the same thing goes for all of these. Sometimes they don't even bend them. So again, this isn't going to be used in any kind of a rough scenario. And you'll notice a lot of the, as I've mentioned many times before, a lot of misconceptions, and of course a lot of parroting between people. They parrot a lot of things. So you'll notice some of the larger test equipment companies do not bend their leads at all. They'll put the lead, get the noise out of the way there. They'll put the lead into the tube socket just like this. This one here isn't bent, you'll see this. And they'll just leave the tube or the lead in the socket like that, and then just cut off the axis. You see that one? Wasn't bent at all, right? It's just stuck in there. And again, some of the larger test equipment companies that make scopes for industrial application, like the big old Tektronix 500 series scopes, you'll notice that the leads are just put through the tube socket just like that. So they'll put like the component lead, I'll use a piece of solder to illustrate, they'll just put the component lead through it like that, and then they'll solder the component lead. And they'll just trim off the axis. And I do that a lot of times myself. The only reason sometimes that I will bend a component around is if I have multiple components going into that one little hole and I'm worried about one of them falling out while I'm moving the chassis around. Sometimes I'll bend them or put a little hook in them like the person has done with this one here. But for most application, I'll just leave it just like this and put it through. Again, it's absolutely fine. The thing's not reaching maximum G's on an aircraft or something like that, right? So, and of course the amount of movement that a tube would have in here over time, you put the tube in and then it sits there. The tubes have been the most dependable part in this entire radio. No kidding. These are probably the original tubes. So, General Electric tube right there, right? So, they're very, very dependable. That's another thing that a lot of people have a big misconception about. They think the tubes are the first thing that goes. You'll see an old radio like this in a marketplace ad, or, say on your favorite, let me get this on here, like so, on your favorite online auction site, you'll find something like this, and, the first thing the person says is it needs tubes. It has a bad tube. And of course, because that's what everybody thinks. They think tubes are like light bulbs, and they glow like light bulbs, but they sure last a whole lot longer, don't they? So there we go. So this side here is pretty much undone. There's one extra terminal on the top. That looks like corrosion on the lead. That isn't. That's an actual green marked lead. All right, so that is not corrosion. They've marked that lead green. So now, just go on to the top side of the chassis here. I also, I didn't mention this before, these leads here that you see, this one here, and of course this lead here, are for the Bluetooth modification. I figured I'd get a head start and not have to go and solder stuff onto the terminals, but I think I'm going to have to elongate this one anyways. So one of them worked out, but the other one did not. So this one's easier to get at. It's right on the switch here, so I'll probably have to put a longer lead on here. And I'll talk more about that as we actually get to that. So, pardon the focus here. Focus probably is not optimal, but now it will be. So here we go. I'll zoom back into this. And again, take pictures if you need to. You know, we have one lead running into the back and one into the front. It's pretty self-explanatory, but this one here is for the coil. And again, this one's just poked through. You'll notice that it is not wrapped around. It's just poked through. There we go. So now the leads, I haven't really bent them a whole lot. So when this little oscillator coil is put back into place, it'll pretty much, all the leads will just line up to the holes, to, you know, or in the, to the little holes in the tabs of the tube socket. So that's another nice thing. If you go bending these after you remove this or try and straighten anything out, of course you're putting a lot of stress on this. You really want to leave this thing alone. So, you know, if this thing opens up, you know, you're melting the wax off this and you're looking for an open connection after that point. So I've read the resistance readings on this, and for any of you that have this radio that are worried about it, this one here you can't read because it's an open connection, right? So there's only one connection there. But it's 11.4 ohms from pin 3 to pin 4 on the actual, or for number 3 to number 4 on the actual coil itself, and 0.8 ohms across this one coil right here. So if anything ever did open, you have those two readings. Again, this one here you can't read because it's basically open on one end. You just have this little coil right here. All right. So there you have it. All right. So we're just about to the point of being able to remove this, this thing here. It looks like they may have wrapped these ones around. And I'm pretty much ready to remove this capacitor now. So you need a nut driver for these usually. So there it is. So we have all of the parts and pieces now. It's just crusty and falling apart here, right? Look at what's on the bottom side of this thing, right? So it also may be that somebody tried to oil this. So there's a little bearing in the front here, a little ball bearing. I don't know if you can see that. On the back side you can. And this is really hard to move. So this all has to be cleaned out. So when this is off here, what I'll do is I'll spray this down, usually with WD-40, to clean it out, and then I will add some more lubricant after that. WD-40 works very good for cleaning these, but you know, of course, really doesn't have all that great lubricating properties. So I'll end up putting either some grease in here or something like that to make this nice and smooth. And of course, I'll add a bit of lube in here and on the back side here as well. And that way, this will be nice and smooth. This here, the whole mechanism on this, the whole mechanism on here should be super smooth. Like you can tell, this is just dry, right? And when you put side force onto this and try and turn it, you can really feel it bind. And of course, the dial string is pulling this off to the side, right? So it's binding there. And then this is no lubrication. When I put a bit of side force on this one is really hard to turn with side force. So just a little bit of lubrication, you know, cleaning this and a little bit of lubrication, maybe just a little bit of grease behind there, and the dial on this thing will be as smooth as glass. And that's a definite plus. So, nice polarized line cord, right? Look at that, huh? Brand new line cord. These come in a 12-foot length. You can get them at most hardware stores. And they're down the light replacement aisle. So this one here is a replacement cord for a lamp. They come in 12-foot lengths, which is really nice. So it gives you a lot of length, because when you're tying the knot off on the bottom side here, right, you want a lot of length in the radio because you're running this all the way, sometimes all the way around to the switch, or you're routing it around. So it gives you, you know, a lot of extra length. You can cut off and tailor it to whatever you want. So it's better to have more than less. And when you buy these for a lamp, you always want to make sure, again, that the plug is polarized. So look in the package and make sure that one blade is wider than the last. So now, because I'm also going to add that Bluetooth board behind here, what I'm going to do while I'm at it is we may as well just do this all right now, is get rid of this speaker connection on the top here. So it looks like it is wrapped around. Let's see what they've done here. It is wrapped around. So hold that there for a second. And this here, now you got to be very careful. You know, you want to have your fingers here because we don't want to damage the speaker any more than what's already happened in the past, right? It's still nice and smooth and it doesn't bind. It won't vibrate or anything. It'll sound good. So bend that out of the way and take that out of there like so. So that's the audio output transformer. The other lead on the audio output transformer is just grounded here to the chassis. And then of course the other lead of the speaker is also grounded to the chassis. So what I'll do is I'll remove the bracket here. Move this bracket off the front. Get rid of that. And this one right here. I want to hold on to this so that doesn't end up falling and causing any issues. Okay, so there we go. We can carefully remove that, and that allows us to also take this apart if we want, and we can also clean this. And of course, if you don't want to add grease, if you just want to add, a thicker type oil to this, that would be absolutely fine as well. But it's just dry, and boy, is it binding. It's actually the brass has worn a little, so there is side play in this. It's not super tight. I don't know if you can see that. So not a big deal, but not a whole lot of wear there, but definitely a little bit of wear. This thing is magnetic, and what it does is it pulls the screws all the way back inside. You see that? So it's good to be magnetic, but it's also a pain sometimes. So put this here, do that, and just loosen this one here while it's like that. Okay, and to remove this one, probably can do like that. Now I want to hold on to the speaker. Again, you got to be careful with this because you definitely don't want to put any more holes in this. Looks pretty good, not a problem at all. So I'll put that in a nice, safe, very nice safe place where screwdrivers won't get attracted to the paper in this. So move that out of the way. And that also allows me to clean the chassis up a little bit better here and get all of that happening. So what I'll do is I'll find some grommets, size things up, and I'll show you exactly how that goes together. So this thing is just about down to the bare bones now. So anyways, there we go. The tuning capacitor is now cleaned. You can see on the bottom here, I've taken a small wire brush on a rotating tool and just cleaned this area, polished it up. That's where it makes contact with these little spacers here. I also cleaned this, so when I'm cleaning the variable capacitor, what I do is I hold it like this, and then I'll spray the cleaner in like this, and then move this around, and then I'll, again, holding it like this, spray it in here, being careful not to spray this little area right here. So these are the trimmers that set the oscillator and the antenna tuning on this radio, and I don't want to get WD-40 or any lubricant under those little mica spacers there. So after I'm finished cleaning this, I'll dry it up, and I'll take whatever lubricant you prefer, really it's a light oil, and put it in here and then move it around again. And once everything is freely moving, that's okay, and I'll dry all the excess off, and then it's safe to put it up like this again. Again, just being careful not to get it under the trimmers. If you do, you can loosen them off and clean it out, but it's, no need to actually do that. You can see how this here is spaced apart further than this area here. And the reason that they've done that is to actually tune the oscillator and antenna sections here. You can see they've done it with the antenna and the oscillator sections both. And the reason that they have these little cuts in the plates is so that you can move this to make the capacitor track correctly with the dial. So you also want the oscillator to track correctly with the dial as well. So both the oscillator and antenna sections here are both adjusted, as you can see. So if the dial doesn't track correctly, say it's supposed to point at 1000 AM and it's a little bit off, you can either pinch these together or space them apart. And again, with the antenna section as well, you can do that in order to make it track. And I'll show you that or explain a little bit more about that in the end as I'm doing the actual alignment. And I'll show you how these are aligned as well during that alignment procedure. So this is all done. So these are the rubber grommets that I'm going to be using to replace the old ones here. And you can see they're a little bit thicker than normal. So you'll notice that it has a hole that runs straight through, but if you notice the diameter of this is a little bit smaller than this. They have a bit of a taper to them. So that allows this to get pushed in very easily. So what happens is, of course, gets put in the chassis first, and then what you do is you press these in once this is in the chassis, press that down to the bottom, and you'll notice on the top side here, there's just a little bit of space. Hopefully you can see that. Is it focusing? There it is. Maybe I can zoom this in just a little more. So there's a little bit of space there, and once this is in the chassis, right, you press this through and it expands the grommet a little bit, so it makes it nice and tight in here. And then that little bit of rubber on the top there will be pinched against here and make a nice tight fit. So this doesn't want to move around at all. So getting the right grommet or spacing them is very important, and these grommets just happen to be just right. So these will probably work for many radio dials or many tuning capacitors, and of course make the everything work correctly. And this is what I use. It's just a standard grommet kit, and they just happen to be the right ones. So I'm not sponsored by these people whatsoever, so BE, you're welcome. If you're working on a radio receiver, they are perfect for that. So these are nice and thick, kind of an odd grommet, but they work very, very well. So in order to put these in the chassis, I'll put the tapered side down. So get this out of here. And they fit in the grommet really, or in the chassis very easy. So they move just a little bit, not very much, just exactly what you would want. They're nice soft grommets, so you don't really have to tackle with them all that bad. They kind of just pop in there. And again, tapered side down, like so. And then you take these little spacers and then put them through, like so. Just like that. And then the capacitor just sits right back on top of this here again, and I'll tighten down all of those screws. So I'll put the screws in and get that all back together, and that'll be good for the long run. Here's a little tip that you may find useful. So if you want to get oil in these little brass bearings, it's actually very easy. So you notice this one here only does a half turn. So if you spray it on the end, a lot of the time it isn't enough to make the actual oil travel through. So what you can do is you take a rubber grommet just like this. I've already done it to this, and this is smooth as glass. You take a rubber grommet and make sure that it's just a little bit bigger than the shaft size and a little bit bigger than the C-clip right there. You don't want to have to remove that C-clip unless you absolutely have to, because a lot of the times you'll deform them, and they're really hard to make them fit properly again. They're kind of a one-time use thing. So if you don't have to remove it, why do it, right? So put the loose-fitting rubber grommet on here. It'll seal on this area here really nicely on the top. So put that on there, and then what you do is you just spray a little bit of lubricant in there. So just spray just a touch of lubricant in there, just like so. Give me a second here. So there's lubricant in there. What you do is you take your thumb, put your thumb on top of it, and squeeze. And what it does is it acts like a piston, and it pushes the oil right through out of the front. So you can do that a few times. So if you don't see it the first time, spray it again with oil, and then carefully hold your thumb on there or whatever and press this. So it acts like a plunger and pushes that all the way through, and you get lubrication right through that entire little brass bearing. I think you can actually see it on the front side there. So that also works very well with small computer fan bearings, the little roller bearings that are in there. You can put grease in that same rubber grommet and press it, and it'll press grease right into the bearing. So that works very, very well. So there it is. Yeah, you can definitely see it's on that side there. So once that's all done and it moves smoothly, this is as smooth as glass now, you want to take a rag or a cloth and wipe this all down to get all the excess oil off of this. You don't want any oil running down this pulley and getting onto the dial string. Of course, if it does that, you'll get, if it gets on the dial string at all, you'll get slippage, because this, the string has to bite into that little area right there when you're tuning the dial. A lot of the times these areas are polished, very, very polished. So what I do is I take the polish off with about an 800 to 1,000 grit sandpaper. I'll just take that off. So it's not enough to really harm the string, but it just gives it a little bit of extra grip. And that way, when you put the new dial string on, it'll bite this area nicely, and you won't get very much dial slippage whatsoever, or slippage when you're trying to tune the dial. So a few little tips for you that might help you out. Before I go about reinstalling the speaker and installing the bracketry on the front of the radio that holds the dial string and of course the dial pointer, I want to get the holes drilled for the Bluetooth switchboard and power supply, and that's a little board that I've designed right here that makes a very seamless Bluetooth installation. So this will be installed underneath the chassis. So there's a power supply here that powers up the Bluetooth board, and there's a switching circuit here that does a whole lot, and I'll explain that here in just a moment. So this needs to be mounted on the underside here. Again, I don't want any of the mods seen. If you were to say remove the back side of the radio and look in the back side, you wouldn't see any of this. It's all going to be invisible, or very close to anyways. So this will be mounted on the inside like this. So I have to drill little holes that will mount the standoffs that will hold this little board to the front side of the radio receiver. And I will also need to drill the small holes here that will hold the actual Bluetooth board to the front side. It'll be right by the volume control here. So it'll be on the front side of the radio. Of course, this is in the radio cabinet. You won't see any of this. Now, I'll talk about this here in just a moment. We'll get back to the actual installation of this here. So what this does is you can see these little pads right here. So this here, when you initialize, so you'll tune the radio dial right to one end and it'll turn on the little power supply here. There'll be a little switch mounted on the front of the radio receiver that will turn on the little power supply in here. That power supply will immediately power this circuit up and power this little Bluetooth board up. Now, when it's powering this little board up, it's not going to switch the audio from the radio to the Bluetooth yet, because when these little boards initialize, usually they make a pop noise, and some of the other ones, I guess maybe the little cheaper ones, they'll have an actual announcement in them, which is really aggravating. So you definitely want to do your homework and find the proper board that doesn't have that. So this one's nice and silent, it just has that pop. So what this does is this waits for the Bluetooth board to initialize first. Once this is initialized, it switches the audio from the radio out. So it disconnects that audio, and then it reconnects the audio from the Bluetooth into the board, and of course that switches that into the audio amplifier section here, and then of course you get the Bluetooth fed through the audio amp of the radio receiver here. At the same time, the other set of contacts opens the cathode of the IF amplifier tube. Now, why do I do that? And this is what a lot of people miss when they do these Bluetooth mods, and that's all part of this little board that I've designed here. So why do I do that? Well, it's very simple. Even though you disconnect the audio from the volume control and move it over to the Bluetooth board, the IF chain is still active in here, and it's creating enough noise, and even on a strong radio station, that even though it's disconnected, it will mix with the Bluetooth audio, and you definitely don't want to do that. And you're saying, well, why would that happen? Why would it mix if the audio is disconnected? And that's very simple. So the audio amplifier tube in these radios is a combination of two diodes and a triode. You see these two little horseshoe style plates inside here. There's one on this side and one on this side. So those two little horseshoe plates in there are the diodes inside this tube, and then that center cylinder that you see is the triode. That's the amplifier inside this tube. If you leave the IF chain active by not disconnecting the cathode of that IF amplifier, it's still getting signal onto these plates here, right, into these two diode plates here. So usually one of them is grounded and one of them is active, or they tie them together. It just depends on the actual radio's design. So what happens is you get crosstalk inside this tube because the signal from the IF amplifier is so great, it gets inside this tube here because all the pieces are so close together, and then it gets into the audio chain still. So technically this tube is still letting signal through due to a thing called crosstalk. So these two horseshoe, they look like two little horseshoe plates here. If you look at the actual schematic here, those are the two little plates on the side of the tube there. So those two little T's that you see coming into the side, those are the plates. Those are those two pieces that you see through the glass envelope here, one on each side. And then, of course, the triode, the part that's in the center here, is that little center cylinder right there. All right. The cathode of the actual tube goes straight from the bottom and protrudes right into the top and goes right between those two plates, and you really can't see that. I don't know if you can. I'll try and zoom into this as much as I can. So you can see that little bit of white area there and that little pipe that comes up right between these two plates. That little white area that you see there is the emissive coating on the cathode. So that's the cathode for the two diodes here, and it's also the same cathode that runs through the triode right down into the bottom here. All right, you can't really see the grid because that's kind of shielded in there, but that's the plate in the cathode, and then these two diode plates here. You can see the emissive coating a little bit better there. So the tube gets crosstalk in here, and this is very common in all American 5, all American 6, and even the non-all American 5 and American 6 style radio receivers where the diodes are in the amplifier tube. It's really bad in these particular radios. So you need to disconnect the cathode from the IF amplifier. So you need to open that up. So basically you're going to break this little connection, and that's going to float the cathode of this tube right here, and that'll render the IF section nice and quiet so you don't get that mixing effect of say a strong radio station, or even just static if the volume on the radio is turned up. So all very important things. So I'm going to get all of this installed, and then I'll show you exactly how this whole thing works. Oh, another thing to keep in mind that a lot of people don't realize is these radio receivers, they always have just a little bit of hum in the background. And that's because it has a half-wave rectifier, and they don't really have a whole lot of filtering. There's no filter choke in these radios, and there also is no field coil on the speaker. It's a permanent magnet type speaker. So what ends up happening is you always have just a little bit of ripple on the system. So if you put your ear up to the speaker in the radio with the volume down, it's common to hear just a little bit of hum. So if you're away from the radio, it's really not all that noticeable, but just a little bit of low-lying hum in these radios is completely common. So if you have that in your All-American 5 or All-American 6 style radio receiver, it's completely normal. All right, I'll get that board installed and all the wiring and all that stuff, and I'll explain exactly how this works, and I'll give you a demonstration. So this, oh, by the way, this board here and all the plans to build this board are available on my Patreon page in my Patreon electronics course. So all the attachments, so there's a printed circuit board layout there, a schematic. I talk about how to install these, and there's a component layout map. There's actually 2 component layout maps, and you can also use that component layout map to lay on the front of the chassis and punch the holes so that you get the sizing absolutely right. So there's a drill size file in there and all that kind of stuff. It's all part of that component map. So all of this stuff is all available on my Patreon page. You can build one of these things for yourself. These things assemble very, very quickly. They look a little bit complex, but this here goes together in about 15 minutes. So very, very easy to make. Anyways, I'll get all of this stuff installed and I'll give you a demonstration. Another thing I should quickly mention, I'll be installing this little switch as well. You can see how nicely that tuning capacitor mounted down there with the new grommets. So this little switch will be mounted right here, and this will do the switching for the Bluetooth board. So there will be no external switches, no nothing. It's all done with just the 2 controls on the front of the radio. So you tune the dial of the radio right to the end, and it'll activate this little switch, and it'll turn the Bluetooth section on. So you don't have to reach around the backside of the radio and turn anything on, and there's no extra switches. Again, this whole thing is basically invisible. As you can see, this is in front of the capacitor here, so you can't even see it. So again, when you're looking in from the backside of the radio, if you were to remove the actual back of the radio, you won't see anything except tubes. This will look completely stock, and that's the way I like to do things. And of course, all of this stuff can be very easily removed, again, if desired down the road. So what will end up happening is there will be a screw that will be put in the front of this capacitor. You see there's 2 holes here. They've nicely drilled those holes already. What will happen is when this comes around, like so, it'll press on this and initiate the little Bluetooth board. So, of course, this is at one end. It won't bother anything. You can see that these holes will not come around and interfere with it. And as this comes around, this will come and just touch that little arm. So these arms can be bent, so you can bend the arm into shape. So it doesn't need to stay just like this. You can actually bend the arm and move it around a little bit and shape these things so that it'll apply the Bluetooth right at exactly the right time. So these are very handy to have. These can very easily be found all over the place. I just got this from my little local electronics shop up here. So this will be mounted to the front of the radio. So there'll be two small holes here, and this will stand off the front of the radio. So it won't be right on the radio. It'll stand off about like so. And again, that will actuate by the dial. So I'll get all of this all installed. And again, I'll give you a demonstration of how this all works. It's a really, really neat system. All the modifications to the radio are done at this point, and before I try it, I need to put on the actual dial cord or the dial string. Everybody loves dial strings, don't they? Dial strings are so much fun. So I wonder what the average lifespan of a dial string person in a factory was. Anyways, so the first thing that we need to do here is put the pulley right to its max. You can hear the new little switch clicking. I'll talk about that in here in just a little bit again. We also need to take this pulley and move it right over to the stop. So this pulley has to be at the stop. Now this is going to move around while we're putting the dial string on in the beginning, so it's not going to be too important, but I'll tell you when this becomes a little bit important. So this dial string is a bit of, well, I guess you could say abnormally painful, just the way that they've done it. They've tied the knots to both knots to the actual spring. They don't fasten one knot onto the little hook here, so it does become a little bit more difficult, but it does even things out, and it allows you to set where everything is going to be, because this has a stop, and this will pull back off the stop when you're working on the dial string. So by moving this around a little bit, you can get everything just perfect. So that's the reason that they've done that, but I'll talk more about that at the time. So if you have a spring in your system, you'll notice that one has kind of an open side and the other side has a complete loop. The complete loop side is the side that will go towards the string. So the side that's open will clip into the pulley here. So the first thing that we need to do is figure out what kind of tools we need for the job. So we obviously need our dial string. A pair of vice grips, small vice grips is needed. A small pair of locking tweezers is nice. The ones with the longer handles are nicer than the shorter handles, just because, of course, the longer this is to the lock, you get more flex up here. So these will lock and hold closed, so that is kind of nice. 2 pieces of silicone wire or a wire with a very soft coating on it. So this is high heat silicone wire, this stuff. And that's about, an inch or a little bit more than an inch each. Just 2 scrap pieces are absolutely fine. A pair of tweezers so that you can grab the string and pull things tight, and some super glue so that you can put a dot on the knots of the string on the actual spring here and get things just right. That's pretty much what you need here, and a whole lot of patience, because you may want to have a practice run, and of course all of these are each one is a different story. So the first thing I need to do is cut a piece off that's longer. Remember, we want to go longer than the original dial string, and give yourself plenty of room just in case you make any mistakes. So I'll just take a whole bunch of this stuff off, and hopefully you can see all this. So I'll just put it to the end here like so, and just size up. Put this on like this, size this up, pull it all the way through. So right now I'm at the end of the dial string here, so I'll probably cut it off to about here, is just to leave myself a safe amount. String is cheap, so who really cares, right? Cut that. Now once you're done with this nylon string, what you want to do is touch the end of it with a soldering iron, because it's going to want to fray a lot. So that's usually what I do. Hopefully you can see this. It's kind of hard to get this all on camera. Just touch it, and that kind of locks it from not fraying anymore. And then of course do the same with the other end. Get rid of your old dial string so you don't get them confused. Usually the old one is pretty crusty, so you don't really have a whole lot to worry about. Just get that out of the way. Pretty easy to identify, I should say. So there we go. So, and that'll stop it from fraying as you're working with it. You're going to cut it again, of course, a couple of times. This is every time that you cut a piece of the string, you should do that. So again, taking note what side of the loop to work with here. Hopefully the focus is maintaining on this. So if this goes out of focus a little bit during what I'm doing here, I have to pay attention to the string. I can't pay attention to the focus all that much and where my hands are a lot, so please bear with me. So I'll put that on there like so, and just, you know, tighten the knot, whatever. Once you've got one of these knots on, make sure it's good and tight. And then what you do is you get some super glue. Now, if you have super glue, preparation is all where it's at. Make sure it's unplugged before you start this, because if you're playing with a bottle and the string is on here and everything, you're going to lose your patience more so than you would normally just doing a dowel string. So I just put a little drop on there. So it's just a little drop on there. And then I'll hit it with some accelerator. You see this? Hit it with some accelerator. And that's already set. In order not to frustrate yourself further, cut the tail off, and then again, just touch that with a soldering iron. So we'll do that right now. Looking at the focus box here, so pardon the movement. There we go. Okay, so that's good. And after long periods of time, just so you know, if you do that with your soldering iron, I have quite a bit of solder on the tip of my iron. It's fine. What you want to do is don't let your soldering iron sit in the holder like that after you've touched something like this. Add some solder to it just so that your tip doesn't go away. All right. Okay, so there it is. There's one. And so now the fun begins. Another thing you want to do is size your vice grips. So take one of these pieces of silicon wire, whatever the size is, and put it on here and size your vice grips and pinch it so that you know it's tight, so that it'll lock, not too incredibly high pressure that you're going to damage the pulley, but enough that it's going to really squish down and give it some good pressure. So pre-size your vice grips, because you don't want to be fiddling with anything while you're doing this. You just want everything ready to go. Again, avoiding the frustration is key. So put this in here. So I clip this onto the bottom one. I'll run this over the top again because I've got a screw on the bottom one here. That's for the switch mechanism that turns the switch on for the Bluetooth mod, which is hidden down here. So again, I'll talk about all that in a moment. So hopefully you can see all this. So this goes in here and up and over here like so, right? So you don't need to put too much tension on it right now. Just keep enough tension so that, you know, the spring doesn't come out down here. If you're worried about the spring coming out, you can push that little tab in or tie it on there, whatever works for you. So the first thing that we want to do is make sure that both the pulleys are over this way. Again, we'll adjust this all later. All right, so this should be at the stop and this should be fully ganged at this point. And then this here goes over the top and around one turn, like so. So I'll zoom you in. Maybe you can see this a bit better if I zoom in. So this goes over the top, like this, around one turn, like so. And then it goes through this area right here, through the center, and then we have to do a turn or two around this. Okay, so you see how it's already trying to turn this back? So what we're going to do is we're going to leave this right up at the top, and we want them both at the stops. And then what I'm going to do now, make sure this doesn't pop off, is pull that nice and tight. So now you see we have spring tension on there. That spring tension here. Always a good idea to be wearing glasses when you're doing this as well. I'm going to put my finger there and hold this tight. You can see that? So I'll put one turn around here. Normally I've got this facing me, so this might be a little bit more difficult the way I'm doing it because I'm trying to show you this on camera. Let's see, put a turn around here like so. Struggle with this a bit so that I can display this. And maybe say a few turns. So I'll go here. String isn't like wire. It doesn't like to fold when you, or to form when you turn it. So put two turns around here like so. Now don't worry about this. You are going to lose some tension. So usually I pull it as far as I can back, and then you are going to lose some tension. So now that you're done with this, make sure that you're not jumping over the actual string. Okay, so now that we're here, now comes the fun part. You want to hold this, put this on here like so. A lot of the time, you might even be able to get just a bit more tension. A lot of the times, once you put the wraps around here, the actual tension itself you're pretty much done at that point. You really can't do much more unless you let all of the string tension off. And if you do that, then you're gonna create a bit of pain for yourself. So what you want to do is put a piece of this silicone wire without it falling into the radio like so on here. So see if I can do this without, again, this is much more difficult to do on camera than it is if you're not doing it on camera. So hold this like so, okay, and then I'm going to put this on here and squeeze that on there. So now you can let the spring tension off because it's holding everything on here, okay? So now that that's done, I'll put something under here to hold this so that you can see what's happening here. So now that that's on there like so, this is fine. Again, this can all be moved, all right? Move this up so you can see this. Again, pardon the focus and everything else here. As I say, this is tough to do on camera because my hands have got to be here and I can't watch exactly what's happening on the camera. So now we need to put a few turns around here. Okay, so we'll go 1, and you have to work behind, so you're working towards the chassis. So you go 1, 2, and 3. Now again, when you're doing this, you want to make sure that the actual string isn't jumping over itself. So you want to make sure that the string itself, you can see here, move that up, zoom you in, so that the string is all in a line here. So make sure that it's not jumping over itself. Now we're at the back side of the actual pulley here. So we've worked our way back, winding it like so. String goes on the bottom and then comes out like so. So since we're going to be putting that onto this pulley over here, this needs to go behind this one so that you can't put it in front of it. It has to go behind. And you may be thinking, well, that's obvious, but when you're doing this, if this is sitting here and you start doing this, you're going to have an issue, right? It'll bind up. So what you want to do is make sure that's close to the front because, again, we're at the back of the pulley, so we're working towards the back side here. So this goes over like so on the back side, and then, of course, now we need to go behind this string, right? We need to go behind it again, like so. Now here's where the little tweezers come in handy. So grab this down here, put this over here, like so. And then this is going to have to go in here. So we'll put this in here behind the string again. So we'll move this string forward and grab a pair of tweezers, pull that through. See, this is popping off. Can't be doing that. Okay, so put this back through here. Like so. Okay. So now that we got all this going on, put this back up here. Hopefully you can see everything. I don't know if you can or not. Probably not. So what I'll do now is hold this here. Okay. Back this out just a bit. So now what I'm going to do is turn this vice grip, and you'll see that spring here. And this will also give me more string on this end now. See, remember how we cut that much longer? Look what we're dealing with right now, right? Because everything has to be pulled tight. So it's always a good idea to leave yourself that extra string. And what I should do is hold this tight and make sure I got that little piece of wire out because I'm going to need that wire. So, okay. So now that I've got this like so, I'm going to turn this, right? So now that I've got that like so, I'm going to turn this. I've got plenty of spring tension on there. Make sure it's like so. Make sure everything is at its top. Now I'm going to grab that other piece of silicone wire that just took off. Put that right over here, right where this is coming into the actual pulley itself. So right here. I'm going to put that here. Hold that there. Oops. Hold that here. Put these on. And now I can let go of everything and relax. Look at that. Okay, so now that that's all done, the frustration is pretty much done. You can hold on to that and just let that sit. As long as you've got good tension on there, you're fine. Now that everything is done, what you want to do is put this through here again. So you can come through the back or through the front. I'll go through the back here. So I need to go through the back side of the spring and come forward. Again, hopefully this is all on camera. So we'll see here. Of course, when your hand's in funny positions and you're trying to make all of this happen, you know, you're dealing with all of that. And through the center of the loop here. And if you don't get it tight the first time, work on it until you get it tight. You see how there's a bit of slack here? I don't want that slack there, so I'll open this up like so and work on it a few times here until I can get that slack out of there. So that's the fun part, is getting this little knot tight when it's so close, right? A lot of the times is where the actual tension is. Again, you can relax while you're doing this, because at this point, pretty much all the frustration is over. You've got all the tension on everything, and everything's just being held for you while you're actually doing this. And that's pretty good, but let's see if we can get it just a touch tighter. Again, the actual knot itself, you know, keeping everything super tight in here is a really good thing, because this will just, the more slack you leave in this, of course, the more it's going to, the tension will be gone. You know, the tension will lower as this is all happening. And of course, it does help to put this on here. Okay, that's pretty good at this point. So now, once you're done with this, you got everything like so. What you want to do is put an extra little bit of glue on here. Again, don't frustrate yourself, have everything ready to go. Dab it on there a little bit, hit it with some accelerator. That accelerator is gone in just seconds. So clip that off. You don't really need to worry about hitting it with a soldering iron at the exact moment that you do it, but you know, since I'm here, I'll just touch it. Okay. Again, don't forget to add solder to your soldering iron tip once you've done that a couple of times, because you don't want the, right? I call that junk solder. Just add junk solder to it. So now what we're going to do is let the tension off, and let the tension off, just like so. And again, since you've pulled this tight, you will lose some tension on there. And there we do. Now what we need to do is make sure the travel is even. If it's not, you can hold this, move this a little bit, and it will even out. That's the nice thing about that spring system. So there we go. And look at that. Nice and smooth, full travel from end to end. And there we go. The dial string is now complete. No binding. You might want to check that, you know, to make sure that you haven't, you know, crossed anything down here or anything on the other pulley. And away you go. So one of the things that has to be done in the end is, you can see when this sits at the stop here, right, when this is closed, when this is completely meshed, this needs to sit perfectly, I guess you could say horizontal. So this here needs to sit, you know, right across. So basically the flat part needs to sit across, and you can see this isn't aligned quite right. So there's a little set screw in here that has to be loosened off before the actual, the dial pointer is put on. So you set this off, you hold the pulley, right, when this is fully meshed. So right now it's fully meshed, so which it should be at the stop, and this is. So you just loosen that off, make sure this is perfectly horizontal, so the flat portion is like this, and then tighten the set screw back up again, and then this portion here is aligned. If not, the dial pointer will, you know, sit off, right? So you want it to sit perfectly like this, and that's part of the dial string alignment procedure. So there you go. Hope you enjoyed. So once you have the tools, and if you do a dry run once and then go a second time with many dial strings, it's just like this. You just need lots of things to hold the dial string tight in certain areas, and this silicon wire really makes all the difference in the world. A piece of regular, you know, vinyl coated wire or whatever really doesn't work that well. So this here is worth buying a small chunk of it just for this, for dial strings. This is number 12. So this is, yeah, well, look at that. I cut the piece right where it says it. So number 12, and it fits in most pulleys, and it's wide enough that it'll squish the entire area. And then of course you clamp this down, and the silicon bites the string very well. And this is the wire that I used on the restoration of my paint oven that I never really showed the restoration of the oven, but I did show the paint oven there, that old sandwich oven that I used for doing wrinkle coat and stuff like that. Anyways, so there you go. So let's take a look on the underside and take a look at the modifications here. I'll get the speaker back in. Oh, I'll show you that right now. So the speaker goes in relatively easy. So you just watch what you're doing. So it fits behind here like so. And then you keep the magnet as close to the IF transformer as possible, and then tilt it and slide it forward. And you've got about, ½ inch or something like that of clearance between that. And now the screws are ready to put in, and it's ready to mount. So just that easy. So this can be slipped in and out very carefully behind this bracket here. Starting to look a little bit more like a radio again with that speaker back in there. So I've reattached the speaker wire. They left a little bit of extra wire here, so I just put a loop in it so that it's not kind of hanging and looking unsightly. So the switch that was added, I originally talked about moving the switch here, but I ended up moving it over here just because the dial string and the actual height of the screws and everything like that. Now, on my end, you can see there's a lot of clearance between this. I can almost, well, pretty much can slip a tool behind the dial string here and the switch. And since the dial string itself is on the front side of the pulley, and then of course the turns work their way back towards the chassis, the dial string will never collide with that. So hopefully you can see the distance there. Kind of hard to get the distance there in the dial string in the closest portion there, right? So it just depends on what area you look at it to see it, but actually there is quite a bit of clearance. Camera makes things a little bit tricky because it really doesn't show that. It doesn't show distances very well in certain tight areas, but there is actually a lot of distance there. So no problems there whatsoever. This will rotate completely throughout its entire travel and doesn't even come close. Doesn't even come close to the actual switch or this screw. I can still probably fit maybe 2 or 3 playing cards between there and the backside. So tight clearances, but absolutely fine. So what I did is I added, that's a little spacer on the backside there, on the backside of the pulley. So you can see that little spacer there. It's a round spacer. It's just used as a standoff for usually circuit boards or whatever, and they're threaded. So I put a small screw through the front of the pulley, and I just utilized what's already here, so the holes are already stamped in the pulley. And then I took that switch and mounted the switch to the front, so I measured where it would be perfectly fine. And again, you can bend these little arms. You can see the slight bend in it. You can bend it to where it's absolutely perfect. So you want it as close to the end of the dial as possible. So, and that's of course when it engages. So at the end of the dial, so we come close to the end, right? And then you'll see it clicks in right there, and that's all we have left. So it has to back up a long way, right? So come to the end of the dial. And that's where it clicks in, and then we have just a little bit more travel. Right, just so that we have that little bit of leeway back there. And then of course that way we utilize most of the dial. So if there's any stations that are right close to the bottom of the dial, you can still tune it in and without it going click. If it does click on, then you just back it up and then tune it in again and you're fine. And then of course if you want to go to Bluetooth, give it that little bit of extra and it'll turn on the little Bluetooth board over here. Now the little Bluetooth board here, give me 1 second, just move this stuff out of the way. So these little Bluetooth boards, they come with a jack here that you can actually listen, so you can plug up some headphones in. So I always test these boards before I mount them. You're seeing this board here, you'll spot these everywhere. They're a very common type of Bluetooth board. So what I do is I desolder the jack off the top of the board, and because there should be a load, right? So that it thinks that there's a pair of headphones attached to it. So my Neumann headphones, they're about 150 ohms each side. So what I do is I put two 150 ohm resistors on here, just a random load. It's not too specific, to tell you the truth. It could be 80, 100, 150, whatever. Obviously, the higher, I'm looking at, the higher the better for a circuit like this. But anyways, 150 ohms on each side. So you can use the pre-existing pads for this one. This one I scratched a little bit off the surface to make an extra pad because the two pads are up here, so they're too far apart. But 1206 resistors fit just fine. The two little capacitors that are going to be mixing the left and the right signal are right here. So what I did is I opened the ground pad here. So if you cut the ground pad at the bottom, you can open the ground pad. I put two capacitors on here, and then of course they're tricky. They put a via on the back side of the board as well that goes to ground. So I isolated that with a little horseshoe pattern. Just an X-Acto knife will cut that out just fine. And so the ground pad is now open on the top, and I can use that as a pad. So I put 2.02 microfarad capacitors here. These are 100 volt rated capacitors, believe it or not. And a piece of silicon wire that runs off that. So the signal is all mixed right on the actual board. Now, it doesn't have to be done like that. The only reason I did this is because of space constraints inside this radio. If you want to utilize other space and run longer pieces of wire off and do things like that, you can do that fine, absolutely fine. You can just solder to the existing pads. You can leave the jack on here and put the resistors in the radio like I did in the Mr Carlson radio that I did around Christmas time. All right, so I just ran resistors under the chassis. It's absolutely fine. So this is just another option. So I figured I'd display that for all of you to see. If you have seen the Mr Carlson radio and the way I've done that, this is a little bit different. So this allows me to run one wire off. All the load and the mixing is all done here between the two channels. So I just can run one wire off this, and that works really good for the underside of the board because it gets pretty busy under here. So we'll move this up here so that you can see things. So the switch wiring that you see here is running off here, runs through a rubber grommet and a hole. I have to be careful because, again, there's a post that will come through the front of the radio and poke through this. So it can't hit these wires. There has to be enough room for that. And of course, the post only protrudes about so far through the back. So I'm fine. There's a lot of space here. Use some pre-existing chassis areas to act as wire restraints. So the wire restraints are held in here. So the two AC wires are the furthest ones down. And then this is the neutral, which is closest to the chassis, spaced between the positive and the negative for the power supply for this board. So you can see the wires that are soldered on the back side there. They come down through here and then run up to the circuit board here, which is mounted to the front now. Extra little hole for another little wire restraint down here just to hold things in place to keep them as close to the chassis as possible. So that's all installed. So I'll back this out just a little bit. So you can see the resistor that opens the cathode of the IF amp is soldered onto the bottom there, onto that pad on the bottom, and then this just carries back again to the ground where the neutral inside the chassis, right down in here. And this does the switching. So the radio's audio that comes off the IF transformer here, right? And of course this, a portion of the detector tube, right? You can see over here, goes to this pad right here. And then the center pad, which is the center of the relay, which is the center contact or common, will obviously be the volume control. The volume control needs to run in because it needs to pick between the Bluetooth audio, which is this far one here, and the radio's audio. So it moves back and forth. The relay moves back and forth between these two contacts, as well as switches the actual cathode open or closed over here. So that's all installed. And what else can I tell you here? I changed the color of the wire just to be close to factory. It says right on the schematic the wire for the antenna is white and green. They had a black wire in here. Somebody had replaced that at some time. Let's see here if I can find that on the actual schematics back here. So I to be correct, white and green, so which makes it a little bit easier for you know, soldering and desoldering on the antenna. The antenna wires I've left are pretty long. They're longer, so the white and the green wire, this will allow, a lot of the times the backs of these radios get damaged because people are wrestling with them to pull them off to the side to get at the tubes in replacement time if it ever does happen. So these are long enough that this can sit comfortably down here without, you know, trying to actually damage the back or pull it out of the way. And then of course, when you put this back together, these will just, you know, form behind here and it's absolutely fine. When you look at it from the back side of the radio, when it's inside, that's what you see. So it looks completely factory. Look at that. Can't see anything. No modifications when this is down inside here. Wants to be down inside the radio. You got the radio sitting about here, right? The top of the radio. About the only thing that is kind of viewable is if you look, if you were to notice it, you might see just a little bit of the arm and you would see that little white spacer there, that little thing right there. But you really wouldn't know what that is, and that could even be painted silver or black and you would not even know it. So from the back side of the radio, this is really the view that you're seeing. So it looks completely factory, right? Which is nice. Oh, by the way, this is, again, high heat silicon wiring. I use a lot of this stuff. So it's great in vacuum tube radios where, you know, this might be touching maybe the converter tube or the oscillator mixer, you know, where it's touching something hot. The silicon wire here deals with some extremely high heat and works very well. And it's extremely flexible, which is another nice thing about it. So I like using this for test leads, replacement test leads and things like that, because, you know, it's very high strand count and it's actually pretty good. So yeah, stuff that can be found, you know, relatively easy on most online auctions and things like that. All right, I'm ready to power this thing up. So let's experience this together. So I can put the antenna on. I guess I could do that right now. So this will be its maiden voyage. This is the green side. That on there. And this one here is the white little W on there. Corresponds, or chassis symbol, closer to the chassis. Another thing I didn't mention just before I power this up is these are insulated standoffs for the Bluetooth board. Again, the chassis is isolated from the rest of the circuit by a capacitor, and the Bluetooth board, because the common is close to everything on here, also has to be isolated as well. So there's a little standoff here. And one thing I didn't show you earlier is there's a nylon spacer below this little screw as well, because it's in close proximity to the head of this very small screw. So that's a nylon washer under there, as well as another insulating spacer on there. So the board is completely isolated because this is actually tied to the ground, to the neutral, because it's the B- of the radio, right? So that's where this, not this, but the ground of the radio, this is the audio out, but the little black lead on the back side there is a black lead that you see right there, runs through here and then comes to the power supply, which is right here, and then you'll see right in the same spot that ground also runs off to the B- of the radio, right? So we have a black and a white wire in there. The black is the ground for the Bluetooth board, and then the white runs off to the neutral. That's where that's going. So anyways, a few more things that I may have neglected to mention earlier. So what do you think? We could monitor the voltage of this thing as it's powering up, but you know what? Let's just see what happens. So it's plugged into my isolation transformer and current limited variac supply, so this is nice and safe. So now, make sure this is just on and this is not on Bluetooth, it's at the opposite end. Okay, so what do you think is going to happen? You see any smoke signals or anything, do you think? You think this is just going to work properly? Here we go, let's find out. Do we have any light in the tube? Usually the rectifier tube is nice and bright. We can see that. Yeah, see that? It's lighting up. Some cathode light in the top there. All the tubes are lighting up. All the filaments of these tubes are in a series string. So if for some reason something is wrong and one of the filaments is open, none of them will light up. Kind of like old Christmas lights, the way that they work. So there we go. I hear static. It has come to life. Listen to that. So there we go. Now again, in the lab down here, I'm not going to really receive anything. So it's, I'll have to couple the antenna from outside with another little device. I don't even need to couple it to the radio. I can put the device close, well, actually feet away, and it'll bring the outdoor signal into the lab here. I'll talk about that. That's also another little project that I've released, a little one vacuum tube project I've released on Patreon that makes servicing these radios a lot easier. I'll show you that here because I need to use it for alignment and everything on this anyways. Okay, so it seems to work, just no radio stations. So what I'll do is I'll turn the volume down. All right, that's just a good practice, good thing to do before any kind of Bluetooth is turned on. So I'll run this to the end of the dial. I'll keep a little eye on the LEDs right here. If this flashes, we know that we're getting power to the Bluetooth board, and then we'll take a look at the board on the underside. There it is. And you hear a little bit of digital noise in there just before everything switches over. I like that. I was going to add another mute relay so that just completely everything goes silent when it clicks over. But when you hear that noise, it gives you an idea that A, the little power supply inside is running, and you know that this thing is trying to work. So you can hear the noises all together, just briefly as it mutes the original pop from this thing. So normally, you know, if that board wasn't in there when I clicked it over, it'd go pop, but that little board that I've designed takes care of all that. So you hear, if you turn the volume up, you'll hear it a little bit. So here's some static here, just low level volume, right? I'll turn it, you'll hear a little bit of power supply noise, and this just before everything switches over. And then everything is fine. So that noise tells me that everything is working in the radio receiver. It's kind of like a little bit of a notification. Again, I was going to eliminate that, but I figured that that was kind of a bonus. Once it's all clicked in and everything is clicked over, everything is fine. So you don't hear any of that. It's all, you know, just silent. You'll hear the hum of the radio and such, but other than that, it should be okay. So now, at maximum volume, I'm already noticing something, and this is very common with the All-American 5 and All-American 6 style radio receivers that don't have a phono jack on the back. Now, these are designed to a price point. Again, the radio looks really nice, but again, these were designed to a price point back in the day. So if it doesn't have a phono jack on the back, a lot of the times they didn't add very much shielding into the audio circuitry itself. All right, so I'll get closer with the mic here, and you'll hear, this is at maximum volume. So that's maxed volume. You'll hear a little bit of audio hum in there. You may or may not. So a little bit of audio hum in there. All right, max volume. So basically the volume, the vacuum tube here is listening to this board at maximum volume right now. Now watch what happens when I go to the middle of the volume control. And then as I come close to ground, again, it's quiet. Middle of the volume control, or, you know, this is audio taper volume control, but you go a little further and up to the top and it gets quieter again. So you hear that audio hum? So that's two different types of hum in here. We have the audio hum, which is basically like open line hum right now. And then we have the actual hum, the AC hum, which is half wave rectification hum. So we have two hums. So we have the hum and that hum there as well. So we have two different types of hums in here. That hum is relatively normal. This hum here can most likely be solved, and we maybe can even solve the other one if it's, you know, too much, but it's kind of okay. It's not too bad, okay? But this here, if you have the volume up and say a song goes away, you really don't want to hear this. You definitely want this to be down at a much lower level. And again, that's because these radios are designed at a price point. So the same thing that's happening here would happen in a radio with a phono jack on the back if it wasn't designed a little bit differently. Normally, when the radio's on, if I was to turn the radio on right now, I'd probably go deaf because this is right at the top. It would give me so much static noise. So in a radio like this, you would never hear this, right? Because you don't have a phono jack and you don't have a Bluetooth board in it. So you would just hear static, right? So I'll do this. I'll get away from it a little bit because it's going to probably go kind of be very loud, right? That's what you would hear. So you'd never hear that hum because this is the normal radio, right? At that volume level, you would never hear that, right? Because the volume's always down here somewhere, right? So you would really never hear that hum. But now that we've added this modification, what this does is this makes other little, I guess you could say, issues in their design, price point design, to crop up. So, hey, why don't we do a little bit of hum troubleshooting in here, and I'll show you the way to lower the hum in All-American 5 and All-American 6 radios, and this even works for audio amplifiers as well. So if you're an audio buff, this will help you out there as well. Hum crops up on all sorts of different circuits, just depending on how they're built. So anyways, let's do a little bit of hum troubleshooting. So first of all, what we'd want to do is put it back onto the Bluetooth, right? Turn it up to the point of maximum hum. And now what we want to do is find out where that hum is coming from on the bottom side of the chassis. So I'll flip this thing over and I'll show you how to do that. All right, I'm about to track down some hum and noise in this radio receiver, and I'll share all of those troubleshooting techniques with all of you. Please note, if you're following along, you're doing so at your own risk. Most all vacuum tube equipment, whether it be a radio stereo system, television, guitar amplifier, pieces of test equipment, anything with vacuum tubes, aside from some space charge equipment, has elevated voltages inside, and that's just how they all operate. In order for me to troubleshoot this, of course, I have to be able to monitor the hum level, and in order to do that, the circuit has to be operating to do that. So again, know the risks and dangers of working on any type of vacuum tube equipment, and again, if you're following along, you're doing so at your own risk. The radio is disconnected from the AC source and the radio is off. The first thing that I want to do is take this jumper clip, and I want to clip this onto the radio's negative or B minus, which is right there. Now you'll notice that all the grounds run up to this one point. I did create a star ground system inside this radio receiver when I did move everything around in here, just because I figured that this is probably going to happen. How did I figure that was going to happen? Well, A, this did not have a phono input. B, this thing has unshielded audio input wires everywhere. So this is just bound to happen. So this allows me to share this troubleshooting procedure with all of you, and this is very useful information, obviously, in getting rid of noise in radios like this, noise, hum, and buzz, and all that kind of stuff, right? So now that I've got that clipped on there, I want to make sure that this is nice and tight, and it'll move around, the boot's pressed down, it's not going to pop off. I'm going to take this, and I'm going to clip this onto a piece of scrap FR4 board. It's insulated on the bottom here so that I can't make contact with the circuit inside, and this is now grounded, the FR4 board. So I have a movable shield. I can move a shield around inside here and find out where the hum is coming from. Since this is the audio circuit right in this area, this is obviously the target area, and that's where the hum is going to be coming from. So now, in the previous video clip, I showed the volume control being at maximum and the hum went down, right? And then I backed the volume control up, the hum came up to a loud point, and then as I go towards the ground end of the potentiometer, it got low again. You're probably thinking to yourself, well, why at maximum volume wouldn't it be maximum hum? Well, the explanation is really quite simple, and this is something that causes a lot of people to blindly replace variable resistors or potentiometers because they don't understand what's going on. So first of all, when the potentiometer is right at the bottom, so it's just about off, right? So we'll go this way. I'm doing this from the back side here, so everything's reversed. So that's off, and then we go click on. So that's at the bottom end of the potentiometer, so that's at the lowest volume point. That means that the wiper of the volume control, which is this arrow, is closest to ground end. So that means the center of the VR is closest to this end. As I rotate the volume control, a wiper rubs along a carbon track, a variable resistor, and comes closer to the other end, which is maximum volume. So I can vary the center between minimum and maximum volume, right? But why, when I get right to the very top, does it get quiet again? Well, the answer is quite simple. So when this is switched over to the Bluetooth connection, so an external source, the output of the Bluetooth board on the front here is a low impedance output. When I have the VR down at the bottom close to the ground end, that's low impedance as well. When I have the VR halfway to 3/4 of the way, depending where that would be in this VR, this is an audio taper VR, so probably closer to 3/4. When I have that right in the middle, that's right in between both of those low impedance areas, and that's the perfect area to pick up hum, because it's not at low impedance here, it's not at low impedance here, it's right in the middle. So that's the reason When we back off from the top end of the VR, we get that hum. I'll give you a demonstration of that right now. So I'll turn this all on, plug it back in here, turn it on. So there we go. I'll let this warm up. I also have to turn on the Bluetooth board. Oh, I should explain that now too. So the switch on the front of the unit turns the power supply on in this Bluetooth board. So it switches the AC line into this power supply here. So you'll notice that when I turn the Bluetooth section on, you'll see this little LED right here go red. When it goes red, that indicates that there's power to the Bluetooth board and that this is in a timing or waiting cycle. All right. When that switches green a few moments later, that tells me that now this relay has switched the audio from the radio out, and now it's connected the Bluetooth board into the amplifier section of the radio receiver. At the same time, it's also opened the cathode of that IF stage, which is extremely important. I'll give you an example of why that's so important here in just a little bit as well. So if you leave the cathode attached, there's a lot of noise still in there. Okay, so I'll give you an example of that VR position thing again. So I'll get my mic close to it here. Hopefully you can hear this. So we're at minimum volume now, and there's just AC ripple in there from the half-wave rectification, okay? So I'll move this up. Oh, I'm still on the AM broadcast band here. I gotta go to the source, there we go. Okay, so now the board is clicked into the Bluetooth, okay? So again, when the radio is on normally, you won't hear that. You won't hear any of that buzzing halfway, 3/4 of the way up, because the radio itself is making so much noise, it just disguises all of it, okay? So here we go. So we're at low volume. So we have our buzz there, and I'll keep going to maximum volume. That's maximum. See how it went down? Now we're going towards the bottom. So it's not quite right at the top. When we go up to maximum volume, it's about as quiet as the VR, ending up at the bottom. So at both ends it's quiet, which tells me that there's no noise being introduced into the actual Bluetooth audio circuit itself. The actual noise is coming from surrounding circuitry. It's just getting into the components and component placement and things like that. So we want the point of maximum buzz, okay? Would be right about there. So we'll leave it at maximum, because in order to troubleshoot buzz, we need maximum buzz. So now, if we look at the schematic here again, this here is a little couplet down on the bottom, hybrid, whatever you want to call it, PC, right down at the bottom. And if you notice, pins 1 and 2 have a capacitor, and then there's a resistor. So we see component A and component B. If we look up over here, we see component B right here and component A right over here. So B is the 6.8 meg resistor here. So that's on the grid line to ground. So you can see it's a really high impedance grid circuit here with a 6.8 meg resistor to ground. And then it runs over here to a capacitor marked 2000. So that's in picofarad. So 2000 picofarad, or if you like, 0.002 microfarad. All right, that's what that is. And then it runs from there over to the wiper of the potentiometer. So this lead from the capacitor on this end over to the wiper is this really long exposed lead right here. No shielding whatsoever. And then, of course, outside of the actual couplet, again, running up to the grid, we have this really long exposed lead all the way down here. So if we take a closer look at the actual couplet, you can see that that's pins 1 and 2. And if we look at the couplet here, you can see pins 1 and 2 down there. So that's going to obviously be the most sensitive area. And you can see how those two leads are further away from all the rest of them. See that? So now, knowing that, we can check this out. So what I'll do is I'll start at the opposite end of this couplet here with just something that'll introduce noise from my body. So I'll start right here, and I'll move towards the sensitive end. And you see that? So you can definitely tell that that's a very sensitive circuit, right? This little couplet here is insulated from everything, and I'm just running this close to it. So you can see how incredibly sensitive this audio circuit is. And of course they didn't shield anything. Now again, these are designed to a price point, and with the radio on, see here, this is at maximum hum here, right? Right, maximum. Well, if I switch the radio on, you're not going to hear anything in that. I can hardly hear myself think right now, that's so loud. If you turn the volume down, you wouldn't even know it's there, because it just mixes with random background noise. Right? You'd never know that that was there. So when you're introducing new things like little circuits, or again, if this had a phono input, they would have taken care of that. So the difference is with their phono circuit, as you move to the top end of the VR, it wouldn't, it wouldn't get noisy and then quieten up again at the top end. If there was any line hum in there, if there was any open line hum, as you move to the top of the VR, it would just get noisier and noisier and noisier until you get right to the top, all right, with nothing, because the top is basically an open connection, so it's the highest impedance or resistance, if you like, portion of the circuit at that point. So that's what it is. So definitely check VRs before you replace them. If you think that, oh, it's an open track or something is wrong in the VR, definitely check. Don't blindly replace any VR, because that's quite common in other circuitry. In fact, I've run across that quite often in pieces of equipment that have just been designed that way. Way back in the day, a lot of the hum or the noise, pardon the bump there, a lot of the noise or the hum in other circuits, some circuits were designed to actually have a source attached to them all the time. So it just depends on the piece of equipment, right? So anyways, so we want maximum hum here again, so we'll get the mic in there. All right, that's about maximum noise right there. So now if I take my shielding and I go on this side of the couplet here, between the line cord and the couplet, let's take a listen. Hear the hum going down? The hum level is changing. I'm holding onto the boot here, and so I'm not part of it. So you hear that, right? So we know that chances are there's some noise coming in from this side of the couplet, right? Because it's not a double-sided thing, right? It's a single-sided piece of ceramic in there, right? So the AC line cord is coming in right here. So it's listening to the AC line cord. Now, when I added this new board, because this is basically the only area I can put that in there, we have an AC connection right here as well, and the grid connection to the tube is right here. Right? You see the distance in there? So I'll run this between that, and let's take a listen there. Hear the difference? Quite a difference. So the hum compounds, right? It adds up. So we have some here, we have some down there, and then we have all of these open lines here, right? This is an open grid line, so that's a very sensitive portion of the circuit. And same with that, it's just out in the open like that. So technically, all of this needs to be shielded up to get the lowest amount of hum possible. So hopefully you can hear the differences here, Get real close to this. So all of that adds up. So shielding these leads really is a no-brainer. That has to be done anyways. You can't have open audio leads like this all over the place. And then of course on the bottom, so that has to be done. So I'll get that shielded up, and I'll cut a few small pieces of this FR4 board, and I'll just add some shielding in there, and I'll show you exactly how I've done that. I'll most likely take the back side of a piece of small FR4 board and run it in between this area here, right? So hold this up here, put it in there, and since the chassis is AC ground, I'll bridge the maybe a connection from that screw there over to the other side, so the insulated portion is closer to the AC side there. And that should give a piece of shielding between the AC line, and then I'll maybe add another piece in here and shield these leads. And I think that should probably lower it to a point to where it would be acceptable, right? Now, keep in mind, this is 3/4 volume, and that's full volume. A huge difference in buzz, eh? So you only have the AC ripple in there. which isn't very bad. When it's in the case, it shouldn't be too bad. But that open line hum is the stuff that you hear. So you definitely want to get rid of that. So we'll get that all done. And let's take a look at the results, see what happens. And if we still need to troubleshoot more hum, we'll go troubleshoot some more. Here's a neat little trick to shield leads from components like this. So what we're going to do is use a piece of coax to do it. And we're going to get pretty tricky with this little piece of coax here. So this is a piece of RG316 or similar. And of course, the jacket diameter and everything depends on, the lead thickness and all this, but I'll explain more about that as I'm going along. So the very first thing that I want to do is trim a little bit of this off. So I want just the center conductor and the insulator showing from the center conductor here. So the order of this is a little specific. So I'll move you down here to the bench and we'll do that. So what I do is I take an X-Acto knife or something similar and put that here, or maybe even a little further up, okay? And be very careful with your fingers, and then I roll the coax, just like so. And by doing that, just move this back and forth, and you can pull the insulative jacket right off, just like that. It's kind of nice, right? So I don't want to cut through this because I don't want to cut through the center conductor and the jacket yet because I need to put a little bit of force on that. Okay, so the first thing I want to do is trim all of the, my clippers here, just trim all of this insulation off. So I'll just trim that all off for now. Again, a little bit of a process, but well worth it in the end if it gets rid of all the hum, right? So it doesn't need to be perfect, just get rid of the most of it. So now we have that jacket here, which is Teflon. That's the center conductor, and that's Teflon. So now what I want to do is I want to take just a little bit more of just the outer insulator off of this coax. So let's see, we'll say to maybe about there. Okay, so I'll just roll this on here again. In fact, I'll just do it this way because it's a little bit easier for me to do. Of course, always being careful of your fingers, right? So there we go. So now what I should be able to do is just pull this off. There it is. Now that that's like that, what I want to do is just tin the end of this. So I just want to tin the end of that, making sure that I can trim off any excess little hairs or anything later on that's not too big of a deal. So hopefully I can do this all on camera. I'll do this. This stuff soaks up solder like crazy. So silver wire, right, and all that kind of stuff. Really good coax. So hopefully you can see this. I don't know if that's going to be too much in focus there, but let's see if we can get this a little closer to the center. You just touch it and it soaks that stuff up like crazy. So that's it. So just to tin it just like so, okay? Now what I want to do is look back up here at this and roughly size up what I want to cut off. So I'm going to say I want that to go from about this area here down to the pin on the hybrid. So I can cut this off, right? So now I've got two pieces of this. I've just cut this off. Okay, just like so. Now that I've got this one end tinned and this end here exposed, what I could also do is put just a little bit of tinning on there. That is kind of handy in the end. Okay, so what I'll do is move you back down here. Again, it's a bit of a process. It has to be done in steps. So I'll put hopefully this on camera here, just trying to make everything viewable. When the camera's this focused on things too, any slight movement, I move my hand just a little bit and it's out of the focus area. So give that just a little bit of a twist there. Hopefully that's going to be enough for me to pull this off on the end. There it is. Okay, so that's nice. Okay, so that's a nice clean area. Again, my soldering iron here, and just tin this up. See that there? Focus on anything here? And probably not. Maybe we can get this a little closer to the bench so you can see this. And pardon all the noise, lots of traffic here today. Okay, so that's tinned up on the end there really nicely. Okay. Now, what I want to do now that I have this little piece prepared is I'll move the end around just a little bit like so. Move this end around just a little bit like so. Back this out so it's a little easier to see now. Then all I'm going to do is take a pair of pliers that have got very good grip. I'll grab this, move this around a little bit, and I'm going to do this. I just pulled the center right out of this. I've got a piece of shielding now. The next thing I want to do is remove this obviously from the VR and straighten that lead as much as I can, and then slip a piece of heat shrink tubing on there. Now cut the shrink tubing just a little bit longer because you can always cut it shorter because it usually shrinks down. And then shrink it up. You always want to go at this heat shrink tubing from all angles because if not, it won't shrink completely. And that is rather important to get this through that center. Okay. So that is all done. I want to wait for this to cool off so that it gets rigid. It's just pretty soft. Make sure everything is nice and straight. So I want to make sure that this is nice and rigid. So obviously the heat shrink tubing, when it's warm, is still pretty soft. So I want to make sure that that's nice and cold first before I go trying to fit this through there, or it'll bunch up. Now you can, sometimes it's necessary to actually curl the top over and put a bit of a loop in there so it's kind of got a blunt end on it. Sometimes this will catch inside, but if you're careful, a lot of the times you can make it just work okay. I cut a whole bunch of pieces of this because I've got to do more of this down here, so hopefully I picked up the right one. I think it is. Yeah, because I'm going to have to do this one down here as well, right? Looks close enough anyways. Oh, by the way, I didn't mention this. You can flare the ends as well. So you put this in the ends like so and just flare the end. It'll also aid in getting the heat shrink through there and everything else. So make sure this is straight and this is straight, and that'll be your friend. Of course, the size of your coax, see how nice and easy that slips on there? Of course, the size of the coax outer jacket, look at that, perfect piece of shielding. And if you have any little exposed, this might be one of the other ones. If you have any little exposed, you want a bit of heat shrink on this end and a bit of heat shrink sticking out on the other end. I've added the shielding to the audio section and it's made a really big difference. So there's a piece of printed circuit board material on the back side of the couplet. I've glued a small piece to the front side with super glue. There's another shield added down here between the Bluetooth power supply and the control grid, or the input to the audio tube right here. And I've added the shielding to the leads on the couplet here as well. So if we take a look here, the radio's on so I can demonstrate, so I got to be careful here. See on the front side, I've glued a small piece, get the focus down there for you. I've glued a small piece of circuit board here to the front side of the couplet, and as you can see, it's grounded to the rear piece. The reason that I have a ground here and a ground here is just to make this extra rigid, so that really holds that couplet steady now. I'm kind of concerned about the little leads that come out of the couplet. They're very fragile, and of course if this is moved around just a little bit too much, one of those leads is going to break out of it. So this will keep it safe for the future, makes things a lot more rigid, and it actually adds shielding here to one of the most sensitive areas of the couplet, and that made a huge difference gluing this to that. And you can see the shielding is run to the center of the tube socket, and that is running to the cathode area of the tube here, and then of course that runs off to the star grounding system. So the cathode is lifted by 100 ohms, but all of the grounds here are attached to this one area and over there, and that seems to be a nice area for extremely low hum. So as you can see, each of the tube sockets, they've got these little buttons in the center of them, which basically hold the two layers of the tube sockets together and keep the little pins in there, or the little legs that come out of the tube socket. And it also acts as shielding around this area as well. So they're soldered into that area. I'll zoom in just a little bit more here and take a look at that there. So you can see the number 14 wire is just soldered into here, and it runs up here and over here to the shielding. And that made an incredible difference. Aside from the ripple that's, you know, still from the rectifier over here, this radio is nice and silent now. So what I'll do is I'll move the volume around, and you can take a listen. So I'll get close to this with my mic, and hopefully we're not going to have too much noisy traffic as I do this, so you can really hear it. Again, the heating system's on, so ignore that. So here we go. The hum you hear is from the radio. Almost no difference. Nice and quiet. So now, aside from the AC ripple here, so what I'm going to do is remove my mic and move it close to the speaker here. So pardon the noise for a moment here. That noise you hear is the ripple. And that, of course, is because of the half-wave setup here. Give me a sec, I'll just move this back up. Pardon the noise. So that is because of the half-wave setup over here. I've gone this far. Why don't I design a ripple filter and put a ripple filter in this thing and make this thing almost silent? So maybe I'll do that right now and add that. I'll be right back. Custom designed for All-American 5 and All-American 6 style radio receivers, the custom ripple filter. Now, this ripple filter can be called all sorts of different things, and people will debate the actual circuit until the day is over. So I'm going to keep it simple and just call this a ripple filter, because that's exactly what it's doing. So there is a lot of ripple present in All-American 5 and All-American 6 supplies, and this brings it down to a level where it is extremely low. And I'm going to show you this on a scope, how incredible this circuit works. And really the magic is in the device. So the pick of the device really is very important, and these little parts that you see here are almost 1,000 volt rated components. So of course they're high voltage. There are the other factors that really make this important. I could dedicate an entire video to this, but this is a very, very important component to have picked right. I tried multiple different types of semiconductors, and this one here by far just really shone and did a fantastic job. The part itself is an F-pack part, so no mica spacers are needed or anything like that. The part just can bolt directly to a metal chassis and use it for heat dissipation. The power dissipation, if you like. The part itself, these three parts here in service, don't really need, in this particular application right here, don't even need to be bolted to a heatsink or screwed to a heatsink. They get gently warm in service, but this acts to hold the actual board in place, and then there are some leads that run off to the existing supply here that act as other support on the front end of the board that's really rigid. You can lift the entire radio up by that, right? So that's the reason that I screwed it to the back. Three nice blade type screws here, all in a row. Looks really good. So I think the modifications in this radio, this is probably the most silent Motorola radio that has been produced. Maybe one of the most silent All-American 5 radios now that is actually out there. So it is filtered so incredibly well. It's and everything fits underneath the chassis too. And you know, you look at the top side of the chassis again, and you know, you just see extra screws, but you would never know that. You know, you would just never know there's a bunch of screws in a line here. And there are extra holes punched in the chassis right from the factory. So, you know, a bunch of unused solder tabs and these holes up here, there's holes everywhere that have just been punched and left alone. So it just kind of fits in. And from the top side, all the modifications, all the tubes are still in use. Everything is still in use in the radio. And of course, the entire amplifier section is in use during, you know, the Bluetooth. So everything is working on this radio receiver. I added one extra component to ease up the rectifier and to also take the drop of the filter circuit out, and it brings it right back to the voltage spec again. So on the bottom side here, you'll see this, I have this piece of paper here. The only reason I put this under here, it's not on right now, I don't really need this, but when this thing is on, the tubes get very hot, of course, and this is a soft mat, so that's the reason I put this here, to kind of shield the mat from that as the tubes slowly sink into the soft mat. Anyways, I've added a diode here. So the diode is a 1000 volt rated part. Again, greatly overrated. It's a 3 amp part. I want the power supply diode rated higher than the fuse. So that's very important. So if something fails in the circuit, it's most likely to take this out and not destroy the diode. So things like that. Lots of different I guess a lot of thought process went into this here. Now the diode itself is basically bridged directly across the rectifier here. So it goes, directly right across the rectifier from plate to cathode. And the tube is still in use, so it's acting as the filament drop for the rest of the line, except it's just idling now. So the nice thing about this is if something ever was to go wrong in the radio receiver again, it completely protects the cathode of the tube. And of course you can add much larger capacitance to this if you have a solid state device there, right? The limiting factor for the capacitance, and the reason that they use such low capacitance here, is because the little cathode strip that connects from the cathode itself to the lead out pin in the vacuum tube is a very small little strip, and it can't handle very much current. And they also have this here to limit the current as well, as it's charging this 50 microfarad capacitor. So now with that, you could add, with this particular diode, you could add just absolutely tons and tons of capacitance in here. You'd have a big filter in here. Of course, you'd have to size the fuse to deal with the inrush current, but there is absolutely no point. So this filter circuit here, for the fun of it, I tried a 560 microfarad capacitor rated at 200 volts and put that in the circuit, and this does way better than that capacitor. So I've added a small capacitor here right at the transformer point, right? So right here where it feeds into the transformer, because the very first thing that's out on the output of this board, it runs to the transformer, and then everything else runs through this 1K ohm resistor. So you can see we have the out right from here, and it runs solely up to the transformer, right off the rectifier stack, right off of this, and that's where most of the ripple is, right at that capacitor there. So that was replaced with a 47 microfarad capacitor, right? Factory kind of design. And then, because now the line is actually broken at, I would say, well, the capacitor would have to be moved over, but it is broken at this point right here. So it's broken at that point. The filter is put in there, and so it filters this way, and of course, it's going to filter everything up to even the audio transformer. Most of the ripple is present on the actual audio transformer. We have another 1000 ohm resistor right here, and then we have an extra 30 mics filtering. Of course, that's up to 47 as well, because it's no big deal. And then now, after the filter, I've added 10 mic just right at the bottom portion of the filter. And I can get into explaining that. That's a lot to deal with impedances. And then, of course, when you turn the volume up, what's present on the line and everything like that. So a little bit of extra filtering right at the bottom there, which is this capacitor right here. Questionable whether it's actually needed. I added it there for basically good measure, right? It's good design measure. So that's there. So, the capacitance of this circuit is equivalent to a lot of capacitance. Now each one of these little devices here has drop across it, right? And the diode here brings that back up again. So when you put a solid state device across the rectifier, the output here goes from about 130 volts up to about close to 150. So then the drop across the devices and everything bring that right back down to 130 again, or very, very close to. So it worked out just absolutely perfect. So very, very good modification. Again, protects the actual tube if anything goes wrong in the circuit. And the tube is still in use. It's still acting as a drop for all the rest of the filaments. It's just that it has a little bit of an easier life now. And we get the absolute correct voltages. Now, you don't need the actual diode. If you want to have a little bit of voltage drop and to run the radio just a little bit easier than factory spec, you can leave the diode out and just run the factory rectifier into this. And it's absolutely fine. It'll just take that 130 down to maybe about 115, and you'll be absolutely fine. So something like that, about 5 volts drop across each device there. So, and the current that's being drawn in the circuit is so minimal. Again, they just, you know, all 3 of them, they get, you know, just warm to the touch in service. So now that they're bolted to the back, we have lots of leeway, or screwed to the back. There's lots of leeway here and sinking and everything like that. So this thing here should be good for the long run. So anyways, what I'll do is I'll power this up and I'll let you listen to the speaker now and take a listen to the ripple that's left over. Here's an example of the hum that's left at the speaker with the ripple filter now installed. Now keep in mind there's a Variac humming behind this, so please ignore that. So to give you an idea, the microphone is very, very sensitive. I have to put my head right up to the speaker to hear any type of hum here. So I'll give you an example of before as well. So here is the result before the ripple filter. That noise you hear is the ripple. And that, of course, is because of the half-wave setup here. So quite a dramatic difference. In fact, an incredible difference. I'll attach the scope and let's take a look at the difference from the input to the output of that ripple filter. Here's an example of the ripple with the scope roughly at 5 volts per division. Now keep in mind this is the input to this filter. So this is very close to the way the ripple looks from the factory on the cathode of that 35W4, and that's being fed directly into the audio transformer. Notice my scope probe? I like to do that because more often than not you'll slip off of something and that little steel ring, which is grounded right here, this little steel ring, will come in contact with something and then bad things happen. So don't ask me how I know this. So just slip this on here. That way if I slip, I don't short anything out and make a lot more work for myself. So that is clipped onto the neutral here. Again, this is on an isolation transformer and current limited Variac supply. And the inputs to this thing are isolated too, which are kind of nice. It's one of the perks of the scope here. So let's take a look at the ripple at the input. That's right here. Look at that. These are almost flush cut here, so it's kind of hard to keep that on there. 20.6 volts, peak to peak. And without that diode in there with the factory 35W4, it's close to that. That is a lot of ripple that this little circuit here is dealing with. Let's take a look at the output here. That's on the output. So what I'm going to do now is we're at 5 volts per division. So let's go down 2 volts, 1 volt, 500 millivolts, 200 millivolts, 100 millivolts, 50 millivolts. And that's what we're left with, about 18 millivolts peak to peak worth of noise. That's disconnected. Disconnected, it's picking up more noise. That's it connected again. Go down one more step. Now we're at the 20 millivolt reading. So very close. Now you can see the bobbing. This is because the circuit does not regulate. So that's the line voltage changing here. So it's actually seeing the change in the line voltage. That's probably people in the neighborhood turning their stoves on and turning different appliances on. Different things are cycling all over the place. So that's the actual movement of the AC line that's causing this movement here. Again, not a voltage regulator. This is a filter. So there we go, say 22, 24 millivolts, right? If we go up one, right? So 17 millivolts with it reading 15 millivolts, probably ignoring more of the bobbing and stuff there. So probably closer to that. Anyways, we're splitting hairs right now. So anyways, that's the difference. So output, and of course, if I touch this onto the input, it's just off the screen, right? Because we're dealing with 20 volts worth of ripple. And that's how effective that filter is, and that's the reason that this thing is so incredibly quiet now. So great little circuit. Fantastic little circuit. Very happy with the results of that, and this will end up in many more of my All-American 5, All-American 6 style radio receivers. I just quickly designed up the circuit board I'll probably make it a little bit smaller. I may even make a surface mount version of this as well. So again, I'll release all of this in my Patreon Electronics course with a complete explanation of how the circuit works and why it works and all that kind of stuff as well. So that'll be coming up very soon right there. Okay, so now it's time to get into an alignment. This thing needs a quick alignment, and then we can listen to the AM, and we'll also listen to the Bluetooth, see how everything all sounds. I'm now to the point to where I'm about to do an alignment, so I can put the antenna back on the radio and just leave it like that. So the antenna wires are just tacked on here for testing purposes right now, so I'll remove this, remove the bow, and then put the wires on like so. So get rid of that. I need to do this first before I do the next step, and this is another safety step. So after this, the entire chassis and everything is completely isolated from the outside world. So there's no way you can come in contact, or anyone can come in contact with this chassis unless you're absolutely trying to do so. So unless you're, this is on the back side of the radio, unless you're trying to stick your finger in here and touch the chassis or something like that, there really is no way to contact any of the metal inside this radio receiver. Now, they knew from the factory that people would try to attach this to a water pipe or something like that, which is absolutely forbidden with the transformerless set, and that's the reason they isolated this from the chassis. So that really only leaves these two contacts right here. So these are crimped into the back, and what they do is they hold the wires for the antenna, of course, so you don't pull the actual antenna leads off the loop antenna here. So that gives a nice little firm area. They know that this is going to be tackled with over time to check the tubes and things like that, right? So this needs to be nice and tough. So what I want to do is I want to even isolate this, right? Even though it's perfectly tied to the neutral right now and safe, I still want to isolate this just to make it just one step safer. And what I'm going to do is I'm going to install this nylon screw with this insulating washer into this little post right here. So I'll thread that into the post, and that's why I need to solder these wires first, because I don't want to do that after this is in, because it's nylon, right? So I don't want to melt the nylon. So I'll thread these in, and that will completely isolate the entire radio from the outside world. There will be no metal exposed that is attached to the chassis. And that is a very, very important thing with an All-American 5 radio receiver. That needs to be held steady, or the wires will come off. This is a 440 tap. Let's go really slowly through this because it is a squared off type of rivet. Perfect. Now, of course, I'll have to resolder those wires before I do that, but threads right in there perfectly. So I'll do that to the other side as well and get that done. First thing to do in the alignment is to make sure that the dial pointer is perfectly across. So you take the dial pointer and slip it on, and what I'll do is I'll use the black portion of the bracket here to compare this to. All right, so this is still tight. Now, another thing to keep in mind, this catches a lot of people off guard, and a lot of people don't realize this, but there's a gearing effect between the set screw and the shaft on pretty much everything that you tighten down. So what ends up happening is as you tighten the gear, the shaft will turn in the hub. And so a lot of the times you have to overcompensate for that. So we'll see if this actually does it this time. You may not be able to see it from your angle, so I need to get straight down in front of the radio here. Make sure this is tight up against the stop. Move this. As you can see, the actual little pointer isn't incredibly tight in there. That's absolutely fine though. Okay, so let's see if it does the gearing effect on me. And it does. So it went like this. So what I need to do is overcompensate for that now. So I'll loosen this off again, and I'll bring it just a little bit off center. And when I tighten it, it should come right to center. And there it did. So there you go. Tightened it just a little more. Hopefully it's still on. It is. Perfect. So that's one of the things with these little set screws a lot of people don't realize. So keep an eye on that next time. Next time you're doing something like this with any type of radio receiver, as you tighten it, the actual shaft will turn. Anyways, first portion of the alignment done. Okay, so what's going on here? I have the signal generator set to 455 kilohertz. The modulation's set at 50%, and it's a 400 cycle tone on that 455 carrier. So basically 455 is, you can picture that like a radio station. So say that's 1000 AM. The 400 cycle tone is like somebody talking. All right, so this is considered the carrier and this is considered the modulation. So if you were to listen to, say this was 1000 AM, so that would be the carrier. It would be silent. You would have a signal on your radio, and then of course if you modulate that by 400 cycles, you're going to have a tone that's, going to go boo on there. All right, so this is known as a modulation. So I just want to have modulation on there because on this meter here, I'm measuring the signal at the speaker. All right, so that's on the little audio output transformer here. I've disconnected the audio output transformer and it's driving this directly. That is a suggested method. Always keep the audio level in check while you're doing this. So what I'll do with this is I'll touch this back to the speaker every now and then and move this just to make sure everything is good. So you want to keep that because you really don't want to be having extremely high audio levels with no load. All right, so a low level signal with no load is absolutely fine. It's not going to hurt the output tube. Again, I've explained this many times. You hear people, again, parroting all sorts of information. The audio output transformer will be absolutely fine with low level audio. It's the vacuum tube itself is a high impedance device anyways. It doesn't care. So here's the audio lead. It's attached to the input probe. See that here, the input probe, to this meter right here. So now I'm just using this as a big scale, obviously, so you can see that. And what I'm going to do is peak up the IF transformers. So the signal generator is coupled into the antenna circuit through a 0.01 microfarad capacitor. This is attached to an isolation transformer. By no means ever is it safe to work on one of these things and attach test equipment directly to the chassis because this is earth grounded, right? So anything that's earth grounded to something where on a standard All-American 5 you can plug it in either way is dangerous. So one of the reasons isolation transformers were invented, right? So this is on an isolation transformer. Now, even though the neutral is fixed on this, right, it's still on an isolation transformer. The device under test is on the isolation transformer. Okay, so this is coupled into the antenna circuit with a 0.01 microfarad capacitor, and I have my 47 ohm resistor across the output leads. Not that it's really needed, but it's there anyways. The output lead of the test equipment. What else can I tell you here? The ground of the meter is attached to the chassis because the ground of the speaker, as you can see right here, hopefully you can see that, down here is grounded right here. So the ground to the actual meter is attached to that as well. So if I turn the volume up, there's a tone on there right now, right? You can see that. I can set the tone with a volume control, and all I'm doing is looking to peak the IF coil. So this is set to 455. So if I attach the speaker right now, hear the tone? That's from the signal generator. I remove the meter. So you never want to overdrive the system while you're doing this. It's always good to hear just a little bit of static or noise in there. That means that you're not overdriving the front end of the receiver, because if you overdrive the front end of the receiver, you're not going to get a proper alignment. So you want to make sure that the level is down so that you can hear just a bit of static or noise in there. And as you peak this up, you may have to correct the signal generator and bring the level down more. So I'll attach this back to here again. Now again, this is just a relative reading, so I'm looking to do this. Oh, another trick I should tell you that hasn't been talked about anywhere that I know anyways. So I'll just lean this on here, so hopefully that stays. Now you'll hear this tone in here, right? You'll see how I've grounded the signal generator to the actual speaker. Now again, the chassis is isolated by a capacitor, right? Now if I attach this to the antenna terminal, where you would think that would be the best place to attach it, you hear that noise? Right, I'll move this over. Hear that noise? That's with it attached to the ground at the actual antenna. Hear that noise in there? So I'll turn that down, and I'll move this back over here again. And Now we have a nice clean tone in there without that buzzing noise. That buzzing noise will affect this as well. And if you're doing this on a scope instead of using one of these things, that makes reading the scope really crazy because you have a low level signal and you also have low level buzz in there. So of course the triggering circuit and everything is being tricky to try and look for that and lock on it, right? So one of the reasons to use a VTVM over a scope in this, just because it's easier to do, right? So this isn't zeroed, it's warming up, so I can zero it again. And I'll clip this back. So this is back onto where the speaker is. So I'll put this here and I have about that much signal. So that's not really, again, all too important. You can set it right to the center if you're more comfortable with that. Give it just a little bit more audio drive. This is on the lowest setting that this meter has. So if I attach this to the speaker at the same time, see what it does? The speaker takes all of the energy and I really have to turn this up loud. That's maximum volume. That's as far as it'll go. Right, so I turn that down, and then if I remove that, it's much easier to get deflection on the meter. That's why I disconnect the lead from the actual speaker. Again, the speaker is, 4 ohm short, right? So what I'll do now is I'm going to peak up the IF transformers. So what I need to do is take this insulated tool and go into the top here. Now you want to use a plastic tool because these are powdered iron slugs or cores inside here. And if you put a piece of metal in there, it'll affect the tuning. So it has to be an insulated plastic screwdriver that goes in there. And what we're going to do is peak this up for a peak and let's see what happens. Now I haven't touched this, so let's see if we're off. Okay, so I'll move this around. Oh, look at that, how far off this is. Whoa! Look at how far off the eye. This is going to have a lot of sensitivity, so I'll turn the volume down some. And we'll keep peaking this. Wow! How far off is this thing? Okay, so I'm at a peak now. Now I need to go to the bottom slug and do that again. So I'll tip this thing up, and there's a slug on the bottom here as well. So you have to get at it through the hole on the bottom here. Hopefully you can see that. So that's right down in there. This is the bottom portion of the transformer. So I'll poke the tool in there, see if we can get any more gain out of that. Wow. What has somebody done to this thing? I need a longer tool. The slug's so far up in the inside there. So I'll probably have to go back and forth and do this multiple times. Somebody's driven that slug way up inside. And it is kind of rigid, so I don't know if I'm going to be able to do that with just this tool here. Let's see if this one will work. This is a little deeper. That's the tip on this is a little finer. Wow, that is crazy. Let's listen to this now, just for the fun of it. Look at how far off that was. It sounded like it had good receive before, right? Wow. So turn that down. I'm also going to turn the signal generator down just a touch. So we'll go down to, say, let's try 800 microvolts. Again, this is just being fed into the actual antenna here. It's still strong. Let's go down to 500 microvolts. Not bad. 200 microvolts. Okay, that's better. All right. Okay, so back on here we go. And let's see here. Maybe a little too low. Oh, putting this on the speaker, not on the actual lead there. Okay, so that is max signal. So we'll go back to, say, 500 microvolts. There we go. So go to 500, and we'll work from 500. Okay, so let's try this again. So I'll move you up to the screen here so you can see that, and hopefully I won't bump the focus. So there, let's move this. Wow, that is way off. Okay. This tool here is a little too soft. So I'm going to have to find another tool that is going to be okay for that. They're usually not that rigid inside. They move relatively easy. It's just that they've got the shoulder on here, and the shoulder's actually hitting. Somebody's taken that the slug. So I'll probably have to go back and forth on this a bunch of times and see what's going on. Is that any better? A little bit. Let's see. Will that reach? Look at this. How much gain this is. Those IF transformers in outer space. I wonder who aligned this last. That's a peak right there. See if I can fit this other tool in here now, because it's probably coming close to where it should be. Yeah, okay, so now I can actually reach it with the proper tool. Somebody's driven those slugs so far into outer space. Okay, so I'll go back to the first one here again and try this again on the top side. Oh, so that's good there. Okay, so let's take a listen to this and see how much louder we are now. Wow, okay. So let's see if we can bump this down to 200 now and take the level down. 200 microvolts. And that's with the volume up. See, we're gaining a lot here. All right, so let's see if the second one is this far out of tuning. Wow, that's in the middle of nowhere. Okay. What has somebody done with this thing? Look at this. Turn that down. So let's go down to, say, 100 microvolts. Turn that back up. Okay, so see what that sounds like at 100 microvolts. Perfect. Now there's lots of static in there because it's actually trying to receive something. Wow. What has somebody done to this thing? 550 microvolts. All right. Okay, so now, pardon the bump there, let's go to the bottom side and adjust the bottom on that one. So that's right up beside the, right up here, right up there. Oh, I guess I must have lost my ground. Did I lose my ground? Oh, I've lost the connection here. There we go. All right, let that settle off. All right, settle off. Capacitor in there. So hopefully that doesn't pop off again. Stay. All right. This one's way up in there as well. Look at this. What have they done in this radio? No wonder this thing isn't receiving anything. So 50, let's go to 20 microvolts. Turn the volume up. That's it. Yeah, we're passing it. That's about it right there. Go back to the top side here again. So much noise in here now. It's picking up just radio stations and noise here. So it's going to be kind of hard to read this. So I might need to drive the audio section just a bit harder. Okay, so let's see if we can get any other peak. We'll go up to 50 again, microvolts. And see if that's a little clearer. Still lots of static in there, so I think I'm okay. Okay, so let's try this again. Now we're at a peak. So now I'll just touch this one here, make sure that the stages are going to be happy and see each other. A lot of the times you see that. We had a bit more of a peak out of that. That might just be noise, might be me moving this as well. I think we're perfect. I don't think we're going to get any better than that. I don't think I've ever seen a radio IF section so out of tune before. What did somebody try and tune this? I don't know what they tried to tune this to. It was amazing that it even had static in the first place. So this thing should receive radio stations like crazy now. And we'll go back to the first one here on the bottom, just to make sure that we're doing good. Look at that. We still got more. It's a good thing we checked. It's always go back and check. Once you tune it, you got to go back again and do it all over again. So. Boy, this thing's gonna hear the bugs crawling around in the walls here. All right, that's about it. So we're good. Crazy amount of receive now. So now that this is done, what I'll do is I'll resolder the connection back up to the speaker. So I'll resolder that connection back onto the speaker, and we'll move on to the antenna and the dial alignment here. The next portion of the alignment is to align the oscillator and of course the antenna section here. So we need to adjust the dial at 1620, which is fully open. So that's not a big deal because all you do is you tune the capacitor until it's fully open. Easy. But now we need to know where 1400 is, because that's where they want us to align the next portion down here. So how you do that is very simple, because you can't tell where 1400 is here, right? So what you end up doing is taking the case of the radio. What you do is you slip the radio back inside, so it's off and unplugged right now, as you can see. So put this in here, just like so. Turn it around. Grab the dial. Put the dial on, like so. Now what I'll do is I'll tune that to 1400. So hold this in as I'm doing this. The 1400 should be right in the middle of 1400, right there. So now that it's at 1400, you can remove this carefully. Slip the radio back out. Move the beautifully painted case off to the side where it's not going to get scratched. And then what you can do is put a little mark on the dial with a felt. So usually what I'll do here is just put a little line here from the brass to the actual case. So now there's a little line in there. I can zoom on in and you can see that. See that little line in there, just like so? So I know right now that that will be 1400. And then, so what I'll probably do on camera, it's a lot more zoomed in. Maybe I'll make that line just a little bit better. Put an arrow on here maybe. And then make this line nice and clear. There we go. So an arrow. There we go. So now I know exactly where that goes to be at 1400. I don't have to move this in and out of the case, and I can keep the radio off the bench for the rest of it. So I'll warm the radio back up again, let it warm up for about 5 minutes or so, just to let everything get to temperature, and we'll start with the other portion of the alignment. The next portion of the alignment is to set the dial tracking to make sure the oscillator is in the right spot. Or of course, you know, if say we wanted to listen to 1000 AM, it might be sitting at 1400 instead, right? So this is very important, just as important as the IF alignment, if you want to know what station you're listening to. So it says to have the dial set at 1600, so the capacitor is fully open, very easy, right at the end, fully open. Just like the IF alignment, they wanted it fully open, right? And now it says adjust for the maximum. So you can just do this by ear. It's not a big deal. You want to listen for the tone from the signal generator. When you hear it on here, you know that you're on frequency. It's just that easy. Now, I've designed another device that I've, again, released on Patreon. It's called the Carlson Power Antenna. So this is a scrap radio antenna on the back, and there's a tube here on the rear of this, And what this does is this allows me to feed a signal from my signal generator, a low signal, remotely, and it'll couple that right into the radio receiver here. And that's very important for the final antenna alignment. You don't want any connection to this. In fact, they even specify it right here. They want you to use a radiation loop. So they have their own little formula for a radiation loop. I think it was 5 turns, it says here. 5-inch diameter, 5 turn, right? Yes, 5 turns. So they want you to use a radiation loop. Basically, it's just a shortened antenna like this, right? Same thing. So what this does is this just allows me to couple in signal from my signal generator. And again, I have hardly any reception down here in the lab. So if I attach this thing to my antenna post, I can put that across the bench and this thing will receive like a normal radio. It brings the signal from outdoors right into my lab, and I don't even have to connect anything to the radio. It's a really neat device. So if you're working on these radios, or even if you just have a radio like this and an outdoor antenna but nowhere to connect it, build one of these little devices and bring the signal right in and sit it off to the side or hide it somewhere, and the radio will use that to listen to the radio signals. I'll demonstrate that later because I have to use the thing to make this receive down here in the lab anyways, right? So I've got my signal generator set to 1620 over here like they asked. So I'll show you that. 1620 right here. And I have the output set to drive this thing at about 1 millivolt, right? So it's a nice strong signal sitting far away here. So if the dial's way off, I'll hear it. It doesn't need to be driven anywhere near that level, but anyways, I'll drive it at that just because. And so now I'll turn the volume up. And now we should hear 1620, but we don't hear anything. Again, like the IF, it's completely in outer space. So I'll move this around. You can hear one radio station in there, probably very strong, but nothing there. So this little trimmer adjustment on the side of the oscillator will adjust that. So now I need to tune this with this at maximum, right, to see if I can hear that tone, 400 cycle. All right, so I'll do that right now. There it is. So there it is. So that's 1620. That's it for the oscillator alignment. So now the fun part comes. Let's see if this is anywhere near even close to tracking. We can do that. So we've marked 1400 here with that little arrow. And our next portion of the alignment is at 1400. All right, so I'll move that right to where the arrow is. Let's see here. Looks pretty close. All right, so now I'll move the signal generator to 1400. And let's see. If not, you have more work to do. So hopefully this is going to work. 1400 kilohertz. Aha! We're doing good. So that's just breathing on it. So yeah, right on the line. So I'll adjust that so you can see it. Right on the line there. You see that without the glare. There you go. Okay, so that's good. So we know that that's good. So the dial's tracking correctly. So where it's supposed to point is where it's supposed to point. So now what we need to do is peak up the antenna with this, with a radiation loop. So that is the radiation loop. I can get this further away. Now I need to peak up this one right here for maximum signal. So let's see if I can get this in here. There it is. Oh. Wow, that was way off, right? Right about there, maximum static, maximum noise. And that's it. That's it for the alignment. Even with the volume down, I can still hear it. So that's it. So this thing should receive like crazy now. That IF was just, that was incredible, wasn't it? That was so far off. And this was just a little bit off, not bad. So the antenna and the oscillator are now tuned and the IF is all done. So now we can listen to radio stations. So I'll attach this thing to my outdoor antenna and we'll take a listen here. Just before I put the chassis back in the case, I had two demonstrations. I was going to show you that light bulb, and I was going to also demonstrate what would happen if we didn't switch the cathode of that IF tube out while the Bluetooth board is on. So I have another resistor here attached to the ground B- of the radio, and it's going to replace that resistor which is disconnected at the board here. So let's take a listen. We're right at the bottom end of the dial and the Bluetooth is on. If I reconnect that tube, so that tube is working right now, that's what we would be listening to. Move the mic closer. So if there's a radio station at the bottom end of the dial, we'd be hearing that, either a music program or somebody talking. So now what I'll do is I'll remove, again, I'll make that stage go quiet because I'll just basically shut the stage off by removing this. And that's how it should be. So that's why it's so incredibly important to switch that cathode of the IF amplifier tube out to eliminate that issue that we would have in the 12AT6, the crosstalk issue. And the same thing applies to other radios. If you have older radios with the octal tubes in them and everything, the detector diodes and the audio amplifier are in one tube as well. So very important to definitely power down that one IF stage, let's put it that way. Here's an example of that safety improvement by attaching a polarized line cord, attaching the hot side to the switch, and fixing the neutral side of the line cord closest to the chassis. So I'll plug this into a regular wall outlet. So it's a regular wall outlet. I'll take the test lamp and attach that again to this bat handle toggle switch over here. All right, so to show you that the line cord is attached, I'll tap this on the hot side here, all right. All right, so there it is. I'll turn the radio on. Now, if you recall, depending on the way that we had the line cord attached, we could get light out of this if I attach this to the antenna terminal right here. Either one, the antenna itself will short both of those terminals anyways. So you can see this, all right? And just to show you on the other one, just in case you're interested, nothing either, okay? All right, either terminal, doesn't matter, right? Now, we see it's off. That's what we want. So now what I'll do is I'll turn the radio off. And see it still stays off. And that's exactly what we want. That terminal and of course this terminal here, right? So that is a very important safety improvement. Again, keeping the neutral attached closest to the chassis in this radio, the polarized line cord, and moving that hot over to the switch. I can't suggest that enough for any of these radio receivers. If you're going to work on one of these things and pass it on to somebody else, that modification really is of paramount importance. It really is. It's late in the evening and there are distant stations coming in from all over North America, sometimes known as DX. So at different times of the day, different portions of the bands will come in strong, and it's often termed skip conditions. So to give you an idea of how that works is if you take a flat rock and say you go to a lake and you skip that rock across the water, well, radio signals do the same thing in the atmosphere. So at different times of the day, different portions of the band will become active, and that's why it has been termed skip conditions, right? Like skipping the rock. So that's just simplifying what's really going on. But right now, the broadcast band has those conditions happening. So we can hear, again, stations from all over the place. Now, if you have a shortwave radio, you'll hear stations from all over the world, not just, you're basically, I wouldn't say local, but, right now I'm receiving stations in North America here. If you have a shortwave radio, you can hear, radio stations on different continents all over the world. So kind of fun to listen to. So that's why shortwave listening is such a big thing. It's kind of neat to log different stations from all over the world and really see how good your antenna is working and how well your radios are working. So right now, the radio is standalone. I don't have the power antenna circuit on. The power antenna circuit is over there with the power supply. So what I'll do is, okay, power antenna here and power supply there. So what I'll do is we'll take a listen to the radio receiver here first, standalone. Now, for those of you that know, reception down here in the lab is very poor because I'm below the earth here a bit. So if a radio receives any signals down here, it's actually doing very well. So we'll take a listen to this thing standalone, see what it can hear radio by itself, and then I'll turn on the power antenna circuit and we'll listen to the band again and take a listen to the differences. All right, so I'll turn up the volume here. Just by the static level, you can already tell that the thing is, trying to receive. Camera over just a touch. There we go. All right, so let's scan the band. Right now I'm at the top portion of the band here. It's already trying to hear radio stations. Amazing. Listen to this. This is standalone, no signal being brought in here. This is amazing. Listen to that.
How much attention do you need to short my shot?
Went back to the car, he stepped in, took off.
What is it? It's a case out of New London, Connecticut, in 1996.
With 1996.
So there's not a whole lot going on in here. So we'll see this whole area actually. So we'll see what a difference the power antenna makes in that area too. Actually from here to about here. There's about the radio station there. So that whole area, that'll be interesting. Just the fact that this is receiving anything standalone is really just a sign that this receiver is really working well. So now we're getting close to enabling the Bluetooth, so you'll hear a bit of digital noise and then it'll go silent again here. So we're getting close to that. One more radio station in there, very weak. And now it's listening for the Bluetooth. So now I like that digital noise in there. It tells me everything is working, but I can imagine some of you are probably going to want to have that completely silent through the switchover. And I'm going to add another option to that little Bluetooth board that you've seen inside this radio receiver that will make that possible. So basically what's happening in here is the switchover is delayed, and the opening of the cathode of that IF tube in there is delayed in that same circuit. So what I'm going to do is I'm going to make that immediate. So if that cathode opens, it'll be silent immediately. And that's really what's happening, is the radio receiver is just hearing everything for a brief moment as the Bluetooth board is enabling and going over that noisy stage, of course, emitting that big pop, that power up pop, and then of course it clicks over, right? So I'll add that option here and again release that in an update on Patreon for those of you that are interested. So I've already had many requests for that modification to make everything perfectly silent. So again, that will happen here very shortly. All right, so let's back this up just a little bit here, tune to a weak radio station, and I will turn on the power antenna circuit and let's see what a difference that makes. All right, so I'll turn the volume up. Actually, I'll turn it down as I click this off. All right. And there's a weak station there, right? So what I'll do is I'll go over here now and I'll turn on the power supply here. So the power supply is on standby. So when I turn this on, what it's going to do is supply this here. The filaments are glowing, but it's going to supply this with the anode voltage for the compactron tube here. All right, so let's take a listen to the difference. Here we go.
Let me show you something else. You're in 2 Chronicles.
Wow.
Look at chapter 8.
Isn't that amazing? And the volume is right down right now, and I can still hear this. So you can hear how loud that is.
She had built in Hamath. By the way, a story.
Amazing difference in receive. So let's scan the band.
My lottery dream home. All new seasons of the shows you love.
No!
It's a very, very handsome.
About face, like, remember our manager Alan going, this could.
Tell the .com/rewards for details.
Now remember, this was all quiet in here.
Bank member FDIC pursuant to
And you guys can tell me crazy, but it's something I want to try to build.
So many stations I'm skipping over here too. They're so close. There's one. One there.
Yeah, Madison, Kansas. Yes.
Right. It was a few weeks ago.
Building a museum down in the undercroft.
So don't wait. If you owe 10, 20, or even 100,000.
He learned of Payne's imprisonment. He badgered French officials.
Clinical psychologist Dr. Sukatra Tobar.
That people need to understand ahead of their
and we're in the middle of the street, and the neighbor has exported back into.
Over and over again.
With your humble opinion, Bert,
Multiple stations there.
And we see this and hear about this.
It was strong, but it wasn't strong.
Stations right up to the end of the dial. So pretty amazing difference with the power antenna circuit on. So this circuit here, again, is available. All the plans and everything to build that just basically from junk box parts on Patreon. Now, I'm still going to design a purpose-built power supply. I haven't had time. Again, I've just been designing so many circuits and releasing so many things lately that I haven't had time to do all this. But this here will end up having a standalone supply, and I will release that here in the very near future as well. Again, all of these things are available in my electronics course, along with so many other projects. All right, so what I'll do here is I will tune this right to the bottom portion of the band again, like so. And now it'll be listening again for a Bluetooth connection. So I'll get a device down here and find a neat song in the YouTube music library, something that maybe suits the radio, and we'll take a listen to that. I'll be right back. The radio is tuned to the end of the dial and the Bluetooth module inside is enabled. I have this linked to a laptop that's right over here, and I found a really neat little song in the YouTube music library. I think that works very well with this radio receiver. So let's take a listen. I think it sounds fantastic. So here we go. I'll try and get a little closer with a mic here. That really does sound great. Now keep in mind that now that this has this module in, it can be linked to a phone, a tablet, whatever else has Bluetooth in it, and music can be played directly right into this radio receiver now. So I really do think that it does increase the usefulness of these old All-American 5 and All-American 6 style radio receivers, especially if you don't have any good programming on the AM broadcast band around you. And you get great sounding music just like that. All in all, I have to say, project successful, and I am very happy with the results of this radio receiver. If you enjoyed this video, you can let me know by giving me a big thumbs up and hang around. Don't forget to subscribe and tap that bell symbol if you'd like to see more great footage on this channel. If you're interested in taking your electronics knowledge to the next level and learning electronics in a very different and a very effective way and gaining access to many of my inventions, definitely check out my ongoing electronics course on Patreon. I'll put the link just below the video's description under the Show More tab, and I'll also pin the link at the top of the comment section. So if you click on one of those links, it'll take you right there. All right, until next time, take care. Bye for now.